Hello, and welcome to the first video in the Starting a PHP Project section. In this section, we will create a new PHP development environment that we will be using for our projects. Then, we will set up a couple of different editors that we can use to write our code. In this video, we are going to create a PHP development environment that we will be using throughout this video series. We will leverage virtualization to allow us to build a common server environment regardless of if you are running a Windows, OS X, or other operating system. The technologies and techniques we discuss in this video can easily be reused to create your own custom environments for projects you may work on in the future. To begin, we are going to install two free virtualization tools, VirtualBox and Vagrant. Next, we will use the website puffpit.com to build a configuration that we can use with Vagrant to create our custom environment. Finally, we will go over the basics of using our new custom environment. Let's get started. First, let's download and install VirtualBox and Vagrant. These are both freely available for personal as well as commercial use. VirtualBox can be downloaded from the site virtualbox.org. VirtualBox is the application that runs our virtual machines. If you are not familiar with virtualization, it essentially allows you to run multiple virtual machines or VMs on your physical computer, otherwise known as a host. This video series is being authored using a Mac. However, you can follow along with Windows or Linux as well, without there being too many differences in our projects or setup. This is the power of virtualization. Let's start our download. While we wait for VirtualBox to download, let's talk about Vagrant. Vagrant can be found at vagrantup.com. As you become more familiar with virtualization, you will find yourself spending much of your time installing and configuring your VMs. Vagrant is a tool that helps to automate this process. It provides the ability to write scripts that can handle the installation and provisioning of operating systems and software. We will go ahead and start that download as well. We won't go too deeply into the nuts and bolts of how Vagrant works. However, they do have well-written documentation on their site that explains many of the powerful features in the application. It looks like our downloads are finishing up. Let's go ahead and install both pieces of software. We will start with VirtualBox. If you are on a Windows box, the installation process will be a little bit different. However, for any questions you come across, you can accept the defaults. Now that VirtualBox is installed, let's run the Vagrant installer. You'll notice as we progress through this video series that we really don't interact directly with VirtualBox. Vagrant will be what we use to start, stop, and connect to our VM. Both installations are complete. Great job. Let's move on to setting up our server. Now that we have the necessary tools installed, we can build our Vagrant config. One of the most useful features of Vagrant is the ability to configure not just the VM, but the software installed on the VM. The configuration is fairly complex and worthy of its own video series. Thankfully, there is a site called puffpit.com that creates this configuration for us. Let's see how it works. We will start in the Deploy Target section. A target is really where we want to run our server. We want to run ours locally. Now we can pick the VM provider and operating system that we are going to use. It defaults to VirtualBox and Ubuntu, which is perfect. We are going to add a single machine, but we should use a more descriptive name than the default. Let's change the internal identifier to PHP-projects and the host name to php-projects.dev. Vagrant also allows you to configure port forwarding. This lets you talk to unprivileged ports on your host, such as port 8216, and then forward them to privileged ports on your VM, such as port 22. The rule you see now is for SSH access. We want to add one for HTTP access as well, so we can easily get to your site. Add another port pair that forwards port 8080 to port 80. Continue scrolling down and you will see a section for shared folders. You can see we are sharing the project directory on the host to the /var/www directory on the VM. The project directory will be the directory that contains this configuration we are generating. We don't need to change anything, but this is important to point out as it allows us to automatically share files and directories between both our host and our VM. In the System tab, you can add additional packages, users, and other system-level features. In the Packages section, we can add Vim. Now, we need a web server. Under Web Servers, go ahead and pick Nginx. You'll see it is installed by default. It is a great, lightweight, yet still very powerful server. A virtual host has already been added for you, but we should update some details. Let's change the server name to php-projects.dev. This is the domain we will set up to access our first test website. Remove the server alias. We don't need that right now. Finally, let's change the document root to match our server name. We'll make it /var/www unit/php-projects. Now let's go to Languages and then PHP. We want to install PHP 7. We'll be reviewing some newer PHP features that require this version. Scroll down and make sure to also install Xdebug. It is a great debugging tool for PHP that makes it much easier to find problems. Now let's go to Databases and select MariaDB. Again, it is installed by default. If you are not familiar with MariaDB, it is very similar to MySQL and can be interacted with at the PHP level in exactly the same way. We are also going to install SQLite. It is a lighter weight, file-based database that we will be using in some of our examples. There are several other options that you can play with. I encourage you to explore the site to learn more about the other options later. For now, let's click on Create Archive and download our custom config. Now let's go to our downloaded file and unzip it. You'll see that it contains a randomly named directory. Go ahead and change the directory name to PHP Projects. We should also move it somewhere other than our Downloads folder. I'm going to put mine on my desktop. Open up a terminal window or command line window. We will need to change directories to our PHP Projects folder. Now we get to see how all of this stuff works together. It is as simple as running the command vagrant up. Vagrant has several commands that we will review in just a moment. The vagrant up command, when ran for the first time on a new configuration, will create your VM complete with operating system and then provision all of the additional applications using the configurations we generated from Puffpit. This initial provisioning will take about 20 minutes on this computer, so we are going to fast forward through the remainder of the process. As you watch it on your screen, you will see the progress of the applications getting downloaded and set up on your VM. Now that vagrant up is finished, let's take a look at some of the other commands. You can see a list of commands using vagrant ? For any one of these commands, you can get help using vagrant help and the command name. The other most common commands are vagrant halt, which gracefully shuts down the VM, vagrant provision, which is used to reprovision or reconfigure the VM if your configuration has changed, and vagrant SSH, which opens up an SSH connection to your VM. You should also now be able to see Nginx running if you visit http localhost port 8080 in your browser. This page has some information about modifying your host file that we will take advantage of later in this series. Now let's take a look at where our project files live. Open up your project folder and find the HTML folder. Open index.html in a text editor. You'll notice this file is the one you saw earlier in this video. Go ahead and add some text to the top of the body. I appreciate it congratulating me, but I'd like to use my own name instead. Go to your browser and refresh. We should now see the page is changed and includes our message at the top. This is great evidence that we are able to edit and view the files in our project folder and have those edits reflected in our VM. We now have a working environment that we can use to write and test our projects moving forward. In the next video, we will look at setting up PHP Storm as our PHP editor. Hello, and welcome to Setting Up PHP Storm. In the previous video, we created a new development environment capable of running our PHP scripts. In this video, we will install PHP Storm, a very popular feature-filled PHP editor. Then, we will create a project in PHP Storm, and finally, we will set up Xdebug as our debugger in PHP Storm. Let's jump right in. You can find PHP Storm at jetbrains.com. Go to IDEs and then click on PHP Storm. Then, click on Download and you can download a free 30-day trial. We are going to use PHP Storm for almost all of the examples in this series. The 30-day trial should get you by just fine. There is one more download button to click on, and that should get us to the thank you page where your download will begin. Feel free to fill out the registration form, take some time to watch their video tutorials, or read their documentation. We will use PHP Storm for the majority of this series. While it is a commercial piece of software, it is packed full of features such as code inspection and refactoring support, and it has a fantastic UI. We will get more familiar with its features as we progress through this series. Our download is complete. Let's go ahead and launch the file. The installation on Mac is as simple as a drag and drop. It will only be slightly more involved on a Windows machine. The first time you run PHP Storm, you will get this screen asking if you want to copy preferences from an older version. For now, I am not going to import any settings. Now we are on the licensing screen. We are going to use PHP Storm as a 30-day evaluation. That should be enough time for us to get through this series before you have to decide whether or not you'd like to buy the software. Now we just need to read and accept the license agreement and we'll have PHP Storm fully installed. There is a bit of initial configuration we can do now to set up the key map and some visual aspects of the software. In the key map you will see several different options. For the sake of keeping consistent with the series, make sure you choose the default key map. For the IDE theme and editor color and fonts, you are free to choose whatever suits you. Personally, I like lighter colored themes, which is the default. I know many developers enjoy dark colored themes, in which case Darkula is a route you probably want to go. You can get a preview of what each one looks like by expanding the preview option. Go ahead and restart if it prompts you so the appearance changes can be applied. Alright, let's get our project started. In this first example, we are going to create a project for the HTML folder that we edited a little earlier in this video series. So click on Create a New Project from existing files. As you can see, PHP Storm has several different ways to start a project. Thankfully, they give a short description of what each option means. We want to use the first option, Web Server Installed Locally. While our web server is technically on our VM, this is really just controlling how we sync files. As you saw earlier in this series, we are able to edit our files in place and have them immediately seen by our VM. So even though our web server isn't exactly local, we do not need to copy or sync files in order for our changes to be viewable. Now we need to browse to our PHP Projects folder. Once you have the PHP Projects HTML folder highlighted, click on the Project Root button above the file list and click Next. Now we need to specify a name and URL for our server. The name can be anything we want. Let's just call it default virtual host. The URL needs to match what you would type in the browser in order to view the page. In this case, we just need to add the port 8080 to the rest of the URL. Go ahead and click Next. Now, we need to enter a path for our project. Since HTML is the root of our virtual host, we don't have to specify a path. So just put a single / here. We are done. Let's click on Finish. We are now ready to edit some files. You can see the file list on the left. One quick tip, if this or any of your other tool menus disappear, you can use this small icon in the lower left to bring the toolbars back. Go ahead and click on it and you will see all of the tools and windows disappear. Click on it again and you'll see them come back. When the tools are collapsed, you can open them again using the text along the sides and bottom of the window. Go ahead and open the index.html by double-clicking on it. You'll see the source code of the file that I was previously editing earlier in this series. Let's go ahead and add another little message to ourselves. Now, an interesting feature of PHP Storm that I was not keen on at first but I have now grown to enjoy is that it auto-saves your files whenever you leave the editor window. Go ahead and see for yourself. Switch over to your browser and go to localhost port 8080. We can see our changes. Well done. Now, let's set up our debugger. This is leveraging the Xdebug extension that we added in the last video. In order to test our debugger, we will need to add a PHP directory and select New PHP File. Give it the name Test. The PHP file extension will be added automatically. Now we have a blank PHP file. We are going to add a few lines to this file. Let's write a small function called add numbers. It will take two parameters, num1 and num2, and it will simply return those two parameters added together. Now let's call the function with both parameters set to 2. Then we can echo to the screen the evidence of PHP's math skills. Go back to your browser and view localhost port 8080/test.php, and you'll see our data being echoed out. Now the fun begins. Go to PHP Storm and take a look at the upper right-hand area of the screen. You'll see a little telephone icon with a red no sign and a little green bug. Click this icon. You'll see the red no sign turn into green signal lines. This means our debugger is turned on. Go back to the browser and add to the end of the URL $xdebug_session_start equals debug. The xdebug session start is the important part. The debug can really be any string. Hit enter to load that URL. Now PHP Storm should be grabbing our attention and letting us know that a debug session is starting and asking us which file is being executed. We can choose the test.php file and click accept. We get an error that seems a bit overwhelming at first. All it is really telling us though is that the server never ran into any breakpoints. Go ahead and close the window. To set a breakpoint, you can click on any line with code in the left gutter of the editor. I'm going to click on our first line. You'll see a little red circle show up. Breakpoints are used when you debug to tell your editor and the server that when the code on the marked line is about to execute, you want the script to pause and wait for you to continue its execution. Now go ahead and refresh our page in the browser and come back into PHP Storm, and you'll see that our first line is highlighted, and there's a new panel at the bottom of our screen. Let's talk through the different areas of this panel. The first panel will contain the current stack trace. Right now, there is only one row in there because we are in the top level of the file. If we were inside of a function, you would see that stack grow by one entry and then shrink once we stepped out. The next panel contains a list of all the variables in the current scope. The scope is really defined by the stack. Right now, we don't have any of our own variables defined, so all you see are PHP's predefined superglobals. You can expand and view arrays and objects as hierarchies. The toolbar above these two panes allow you to navigate through the execution of the script. The blue arrow that points down will execute the current line of code without descending down into any function calls. Let's try it. You can see by the current highlighted line that we are now getting ready to execute our echo statement. Let's finish the script by just pressing the green play button on the left. Refresh the page so we can debug again. This time, however, let's use the blue arrow that points down and to the right. This will step into any functions on the current line. Click it, and you will now see that the next line to execute will be inside of our function. You can also see that the stack now has two entries, and the variable list shows our num1 and num2 parameters. Go ahead and click play again. That is the basics of Xdebug in PHP Storm. You could look through their documentation and search for debug to learn more about how you can use debugging in PHP Storm. We will also see some more examples later in this series. Great work! In this video, we successfully installed and configured PHP Storm. In the next video, we will install a free editor called NetBeans. Hello, and welcome to Setting Up NetBeans. In the previous video, we installed PHP Storm, a commercially available PHP editor. In this video, we will set up NetBeans, a less feature-filled but free editor. Then, we will create a new project just like we did with PHP Storm, and we will see how to use Xdebug with NetBeans. We won't be using NetBeans the remainder of the course, but I wanted to show you how to set up a free editor in the event that after this series you don't feel like purchasing PHP Storm. Go to your browser and go to netbeans.org. Click on the orange download link, and then find the PHP column and click on the download button below the PHP column. This will take you to the download page for NetBeans. The download should begin automatically. Once downloaded, go ahead and execute the installer. Depending on whether or not you have Java installed, this part can get a little bit more cumbersome. If you do not have Java installed and you get an error message similar to this, you can just load that URL in your browser. From here, it is important to note that you are wanting to download the JRE. Accept the license agreement and pick the appropriate build for your computer. The download should start now. Once the download is complete, go ahead and run the installer. You'll need to give it permissions, and you'll probably want to uncheck the Yahoo option. Feel free to leave it checked if you'd like. It will just add an extension and set the home page of your browser. Once the Java installation is complete, you should be able to install NetBeans. Now that NetBeans is installed, go ahead and open it up. From this first page, you can find lots of different links to documentation and tutorials. Feel free to take advantage of those. To start a new project, we are going to go to File, New Project. Then click on PHP and PHP Application with Existing Sources. Now let's click on Next. Now we need to specify where our project lives. Go ahead and browse to our PHP Projects HTML folder. We can give our project a name. We will just use HTML. Then something that is important to notice is the latest supported PHP version is 5.6. This does not mean you can't write PHP 7 code in NetBeans, it just means that it won't recognize some of the syntax. They are working on adding support. You can view NetBeans' bug tracker for more details. For now, we will just use PHP 5.6. Click on Next. In this screen, we will be setting up some of the details that will be used for running and debugging our project. Similar to PHP Storm, we want to run as a local website. we will set our project URL to localhost port 8080, and we will set our index file to test.php. Go ahead and click Finish. We can now see our project. As you can see, NetBeans is laid out in a similar fashion to PHP Storm. There are obviously some functional differences, but it is absolutely a usable editor. So if free is the right price for you, this is definitely an editor to take a look at. Let's check out NetBeans' debugging functionality. Go ahead and set a breakpoint on the first line. Now you can click on the icon with a small edit window overlaid with a green play arrow. That will pop open a browser window that should take you to the test.php page. Go back to NetBeans and you will see that it has paused execution, and you can see a similar debug window at the bottom of your screen. At this point, I think you are familiar enough with debugging that we don't need to step through the process. It is worth mentioning, however, that in NetBeans the controls to step through the script are on the main window toolbar. With that, we now have debugging working in both PHP Storm and NetBeans. Great work! In this section, we have done all of the work necessary to set up our PHP development environment using virtualization. We also now have a couple of different editors that we can use on our projects moving forward. Great job! In the next section, we'll review some basics of the PHP language and see how it can be used to build simple web pages. Welcome to PHP Projects, a video course by Pact Publishing. My name is Michael Lively. I've been an avid PHP developer now for over 15 years. I started my career developing small e-commerce sites, and now I am the manager of software architecture for the largest deal community in the US at slickdeals.net. I have also made somewhat significant contributions in the open source world to the testing framework PHP Unit, as well as my own PHP Unit compatible mocking library called Fake. You can find more information out about me from my website, digitalsandwich.com. In this video course, we are going to learn how you can use PHP to build robust and performant websites. PHP is a fairly easy to learn language. However, oftentimes it can be somewhat of a daunting task to set up projects from scratch. This first video will give you an idea of what you can expect to learn as you take the journey through our example PHP projects. The course is divided into 8 sections. The source code for these sections can be found on our GitHub page at github.com/PHP Projects video. This video series is designed to provide useful information to both beginning PHP developers and seasoned developers alike. Our goal is to give beginning developers a jump start into the world of PHP development, and to give intermediate and even experienced PHP developers some new ideas about how you can leverage PHP with other technologies to build fantastic websites. We will start our journey through PHP Project in Section 1 by showing you how to create your own custom PHP development environment. We'll cover some of the same techniques used in large enterprise development shops, but in a way that is easy to follow regardless of your project size. In Section 2, we will give a brief overview of how you can use your new dev environment to create your own PHP site, as well as review some of the basic features of PHP. In Section 3, we will use a dependency management tool called Composer to get some libraries to help us build a URL shortener similar to Bitly using a popular programming pattern called Model View Controller, or MVC. Then we will follow that up with how we can use PHP Unit to write both unit tests as well as functional tests for our new project. In Section 5, we will use what we learned from testing the URL shortener to see how you can use test-driven development to help us build a user management and authentication system. We will follow that up in Section 6, where we will learn how to turn our user management platform into a scalable web service that can be used by other products. Then, in Section 7, we will build our own social sharing platform using a PHP micro framework called Silex. We will see how a framework can help save us from writing a significant amount of code. Finally, in Section 8, we will continue adding some more advanced features to our social platform, including real-time comment streams and full-text searching. By the end of this course, you should be comfortable taking advantage of PHP in combination with a wide array of third-party resources and tools to help you quickly create and launch your own projects. I hope you are ready to expand your PHP knowledge and application building skill set. Let's build some fantastic applications together in PHP Projects. Greetings! Welcome to the second section of PHP Projects, Introduction to PHP. In this section, we will review some of the basics of how PHP can be used to process a simple HTML form. Then we will see how we can use sessions to help persist data. After that, we'll take a quick break to see what kind of functions PHP has to offer and how you can find what you are looking for. Then we'll take our form example and show how we can save the results to a database. Finally, we will check out some of the basic object-oriented features that PHP has to offer and apply them to our form. Welcome to the first video of this section on handling forms. In this video, we are going to take a look at the basic form handling in PHP. First, we are going to build a simple HTML form. Then we will put together a results page for that form. And finally, we will tie them both together using some basic PHP code. Before we get started, we should make sure our VM is running. Open a terminal and change directories to your PHP Projects directory and run Vagrant up. You may see a message like mine, meaning your VM was already running, or you may see it actually boot up the VM if you didn't leave it running from our last video together. Now, why don't we start by building a simple HTML5 form? We'll open up PHP Storm and create a new directory in HTML called madlib, and inside of that directory, we will create a new file called index.php. This file is going to hold the HTML for the form that we post to the user. This is going to be mostly boilerplate code, so I'll just paste it in. This is a form to collect a series of words that we will use to create a story on our results page. If you've ever heard of madlibs, that is exactly what we are creating. The important pieces of this file that we will be referencing later are the action and method attributes in the form tag, and the name attributes in each element. Why don't we jump to our browser real quick and see what the form looks like? You can get to the form by typing in http://8080/madlib/index.php. This URL will map to the /var/www/html/madlib/index.php file in your VM, which should be pointing to the madlib/index.php file we just edited. It looks like we have a simple form. Now we should get our results page ready to go. You'll notice in the form tag I have set the action attribute to story.php. This will cause the server to look in the same directory as index.php for the story.php file. PHP Storm understands this and has even given the attribute a yellow background to let you know that the file doesn't exist. Anytime you see this in PHP Storm, you can place the cursor over that highlighted code and then use the key combination Alt plus Enter to get some recommended solutions. In this case, we get a recommendation to create the file. Let's do it. This file will be where we display the story using our filled-in tokens. Again, this will be mostly boilerplate HTML, so I'll just paste in the HTML for this file. You'll see that there are some basic placeholders for where our words are going to be. Now we can use the Submit button on our form to see what this HTML looks like. I'm going to go ahead and type in some data into each form input, and then I'll press Submit. Now you see our results page with our story. Now we should wire it up and get rid of those pesky placeholders. Why don't we go back to PHP Storm, and while we are viewing story.php, right-click on the index.php and choose Split vertically. This allows us to view both files side by side. Now we want to map each one of the form elements on the right using their form element name to the appropriate location on the left. Let's go ahead and add a new PHP block at the top of the file. Now we can add a new variable called name and set it to post name. The post array is a superglobal in PHP that will always contain the value of form fields that were posted by the user. The value in the square brackets will always correspond to that of a form element in the submitting form. You can tell that it will be saved to the post array by looking at the method attribute of the form. If the form method was get, then the data would be in the get array. You can also use the request array, which contains records from both the post and get array, as well as the cookies array. We will mostly concentrate on the get and post arrays, but feel free to check the superglobals documentation in PHP to learn more. There is always the chance that when someone posts the form, they won't pass all of the variables necessary. This can result in PHP showing or logging a notice that you referenced an undefined variable. We can use PHP 7's new coalesce operator, 2 question marks, to check and make sure a variable exists before we use it. If you are not using PHP 7, you can do the same thing using the isSet function and the ternary operator. If the value is set, you would return the value, otherwise just a blank string. So now, with these question marks, PHP will check to see if the post variable exists and is set to something other than null. If true, then it will use that value. Otherwise, it will return the second value, which in our case is an empty string. If you get red lines like these indicating an error in PHP Storm, you just need to adjust your PHP version. You can do that by using Alt-Enter and selecting the proper PHP version. I'm going to go ahead and add in the rest of our variables. Now we need to plug these variables into the story below. We will do this by replacing each one of the placeholders with a small PHP block that simply echoes the corresponding variable. Now that we've seen how to do one, I'm just going to copy and paste the rest. Now let's go back to the browser and see the results. Go ahead and refresh the page and confirm that you'd like to resubmit the data. Awesome! We see our story in all of its glory. Now why don't we check out the Edit Story link? It takes us back to our form, but all of our values are gone. We are going to need to figure out how to keep those values around. We will learn how to do that soon. In this video, we were able to successfully take data that was submitted to a form and echo it to the screen. In the next video, we will learn how to save this data to our session so we are able to go back and edit our data using the Edit link. In the previous video, we learned how to use PHP to process form data. However, we ran into an issue being able to reuse the data in subsequent requests. In this video, we are going to set up session handling for our project. Then we will learn how we can store data in the session as well as read data back out of the session. Let's get started. In order to add session support to PHP, really all you need to do is call the command session start. Let's add this function to the top of our index.php file. Let's go to our browser and see what this does. Go to localhost port 8080/madlib/index.php. Now we can right-click and inspect element to open the Chrome DevTools. Then click over to the Resources tab and let's view the cookies for localhost. You'll notice a cookie called PHP sesh ID. This was created by session start. This is your session identifier and it is used to keep your session separate from anyone else's session on the site. I can clear that cookie, refresh the page, and you'll notice that the cookie was added again, but this time with a different value. Refresh the page again, and now you'll see that the cookie value has persisted. If session start sees that the cookie already exists, it won't add a new one and it will reuse the session identifier. Now we should see how these sessions get stored. Instead of using the Mac terminal, I'm going to use the terminal built into PHP Storm. If I run the command php-ri session, it will show me all of the configurations for the session extension in PHP. The first one I want to draw your attention to is session.saveHandler. That describes how sessions are being stored. In our case, it is via files. When you are using files, you can see where the files are stored by looking at the session.save path value. Ours are in /var/lib/php/session. Let's change directories to var/lib/php session and list the files. You can see both of the sessions there from our test. When we call session start, these files are created in addition to the cookie being sent to the browser. Now let's see how we can make use of these sessions. Similar to the post superglobal, all session data is stored in the session superglobal. However, unlike post, you can save values into session and these values will be stored in that session at the end of the request for use later. Let's go to story.php and make sure that we save all of our post data into the session. First, we need to call session start at the top of the file. Then, just below where we are setting our other variables, we are going to set session words to be an array, and we will set the name key of that array to post name, or blank if the name doesn't exist. I will go ahead and paste in the rest of the keys. Alright, now we can fill out our form again and submit it. We see our story again, but now behind the scenes we are storing those words so we can use them again in a later request. Let's click on our edit link again. Now we just need to update index.php to read data out of the session if it exists. Go to index.php. We are going to create some variables here that we can use in the HTML similar to what we did in story.php. First, we will create a name variable and set it to session, words, name, or a blank string if the name doesn't exist. I'm going to paste in the rest of the variables. Now, we just need to set up the values of the input elements using the value attribute. Similar to story.php, we will want to embed PHP tags calling echo on the appropriate variables. So in the name text input, let's add the value attribute, and for the value we will add a PHP block and echo name. I'm going to go ahead and paste the rest. Now go back to the browser and hit refresh. Voila! There is our form still populated with our previous values. There is quite a bit of depth to sessions and how to properly use them. When it comes to securing your sessions and keeping your user data and your site safe, there is a wealth of resources that describe this information in depth. A good starting point is PHP's own documentation on session security. You can find this documentation at php.net/manual/en/session.security.php. In this video, we learned how we could use PHP's built-in session handling to store our data across multiple requests. In the next video, we are going to dive into some of PHP's other built-in functionality and see how we can discover what PHP has to offer. Welcome to the video on useful PHP functions. In the previous video, we learned how we could use PHP sessions to hold data across requests. In this video, we're going to take a quick peek at PHP's documentation and see how we can use functions from the documentation in our project. PHP offers an incredible amount of functionality. Much of it you will get out of the box, though some of it requires some additional extensions to be installed on your server. You can get a great overview of what you can do with PHP through their documentation at http://php.net/manual/en. Scroll down the page and you'll see several sections of documentation. We are going to focus on the function reference. You'll see that the function reference is separated into several basic categories. Many of these sections are pretty self-explanatory. Why don't we take a look at the variable and type related extensions section? You'll notice several subsections. We can start with the arrays subsection. Click on the introduction section. This page provides you with a great overview of the functionality that the built-in array extension provides. Each extension has a similar page that you can reference. Now on the right-hand side of the screen, check the Installing Configuring link. Then click on Installation. Each set of functions will have this page as well. For arrays, all of the functionality is built in. Other extensions, however, will have instructions for what you need to install in order to get access to the functions listed. Now click on Arrays in the breadcrumbs. This page will give you a list of all of the related functions as well as a short description for each. This is by far the best way to get an understanding of what you can do with PHP. I can't count the number of times I have learned something new just reviewing various extension functions lists like this one. Let's take a quick peek at another extension. Click on Function Reference and then scroll to the Database extension and click on Vendor-Specific Database Extensions. Then find the MySQL extension and click MySQL ND. Finally, click on the Installation section. Here, you can see that there are some meaningful instructions. In the case of MySQL, we have already installed this extension when we created our VM. You can verify this by calling php-ri MySQL ND. php-ri can be used on any extension and it will provide information for that extension or a message indicating that the extension is not installed. This is a great way to make sure you have the extension installed. Go back to the documentation for MySQL ND and click on Runtime Configuration. Each extension will have a page similar to this one that describes possible configuration settings that you can use to modify the extension's behavior. Go back to the function reference, find the test processing section, and click on strings. These are all built-in functions for PHP. Let's take a look at the HTML entities function. This function will escape HTML and strings so you can safely echo the data to the browser without causing issues with the remaining HTML on the page. Go back to our form and let's enter in some words. For the last noun, let's add an opening bold tag to the end of the word. Click on Submit. You'll see now that the entire end of the sentence is in bold and the string you entered isn't showing up. This is exactly what HTML entities is for. Open story.php. We are going to use the HTML entities function around every variable that we are echoing. Now we can refresh the page. You'll see it printing out the string like we would expect. We should also fix index.php by adding HTML entities calls there as well. Now we are protected from users mangling our HTML and potentially causing security vulnerabilities. In this video, we found the function documentation for PHP and saw how we can use the documentation to improve our project. In the next video, we are going to explore using PDO and SQLite to store data across multiple sessions. Welcome to the fourth video of this section. In the previous video, we learned about PHP's function reference and how to use it to discover new PHP functionality. In this video, we are going to see how we can create a new SQLite database. Then, we will set up a connection in our pages to that database. Then we will learn how to write data to the database, and finally, we will create a new page that lists the contents of that database. Let's start out by creating our new database. We are going to use SQLite for this database. It is a lightweight, file-based system that is great for small, simple applications. In our terminal window, let's change directories to /var/www. Typically, we want to put our database in a directory that is not directly accessible via a browser. We will go over creating a proper project layout in the next section. But for now, for simplicity's sake, we can create our database in the HTML directory. Change directories to HTML and run the command SQLite3 stories.db. This creates a new database file. Now we need to create our tables. We are going to create two tables. We are not going to talk too much about SQL syntax in this series, but to learn what syntax you can use with SQLite, you can look at www.sqlite.org/lang.html. The first table we will create is our story table. This will just hold a unique ID for our table and the time that it was created. So let's write our create table command. Create table story ID integer primary key auto increment. Time created integer not null. Great. Now let's type .exit to leave the database. To create the second table, let's use some more PHP Storm functionality. In the project navigator, you will see a reference to our stories.db file. Right-click on it and select the As Data Source item. Now go ahead and click OK. You'll see at the bottom of the screen that we are missing driver files. Click on that download link. That will download the drivers we need. Now click on the Test Connection button. You should see a message saying you could successfully connect. Click OK. On the right ribbon of PHP Storm, there is a database option. Click it and you will see that it has our new SQLite database. Click the plus sign and choose to add a new table. We will call this table story_words. Hit the plus sign under columns to add new columns. We are going to add our ID column as an int, and we will check primary key. Now let's quickly add the rest of our columns. Story ID is also an int. Label will be a varchar, and word will also be a varchar. Notice how it shows our SQL as we build the table. In the bottom script window, we should also add auto increment. This will be important for making sure we have unique IDs, and it isn't directly supported by PHP Storm. Let's execute that SQL. Now open index.php. We want to make sure we have a connection to our new database. We are going to use a class called PDO to work with our database. Just after session start, let's create a new variable called PDO. We are then going to create a new PDO object. The parameter to PDO is a data source name, or DSN. For SQLite, this is the string SQLite followed by a colon followed by the absolute path to the file. We are going to use the dir constant to help build that path. Dir is automatically set to the directory of the current file. We will also add a second line to set an attribute on our PDO connection. By setting the error mode of PDO to exception, we will get a nice exception anytime there is an error in our query. Now we want to check and see if our session has a currently active story. Let's add an if check to see if session story is set using the isSet function. If it isn't set, execute a query to insert a new row. Create a new variable called statement, Then we will call the PDO prepare method. This takes a query as its first parameter. The query will use question marks as placeholders for values, in this case our timestamp. These are called prepared statements. They are great for dealing with databases and variables as they take care of escaping our queries so we don't have to. Notice as I typed the query that PHP Storm was auto-completing my table names. To execute a prepared statement, call statement execute and pass it an array of values for all of your parameters. We need to pass time to get the current timestamp from PHP. Finally, we call PDO last insert ID to set the story in our session. This will keep us from creating multiple stories each time we refresh. Now let's go to our browser and view localhost port 8080/madlib. Refresh the page a few times. Now go back to PHP Storm and the Database tab. Double-click on the story table and hit the refresh button at the top of the screen. You should now see our story. Let's switch to the story.php file. Here we want to save our words. Go ahead and copy the same set of code we just added to index.php. Typically, we don't want to copy and paste code like this, but we will come back and clean it up in the next video. Now add a new block of code that will update our words. Just so we don't have a bunch of words build up, we will start with a statement to delete our words. Let's execute that statement with our story ID. Now, we want to insert our new words. You'll notice that I'm only creating an insert for a single row. One useful thing about prepared statements is that you can call them repeatedly with different parameters. I'm going to add one call to populate the name word, and then I will reuse the same statement for the next 4 words. Now go back to your browser and go ahead and submit a new story. Now go back to PHP Storm and see our new words. This time in the Database tab, let's click on Story Words and refresh. We see our data. Great job! Now that we have our data stored in the database, we don't really need to use sessions to store the actual words themselves. Go to story.php and remove the block of code that set the session words variable. In index.php, we need to pull the data from the database instead of the session. So just above where we are setting the name variable, let's create a new PDO statement called story statement. We will select all of the words for this story. Now, we will execute the statement using the ID from the session. Next, we need to create a new variable to hold these words. Let's just call it words, and we will set it to an empty array. A great feature of PDO statements is that you can process each row of the statement using a for each. So I'm going to loop over our story statement and add each label and word to our words array. Below, we can now get rid of session words and just work off of our words array. Now we can add a list of stories to our index.php file. Open the file, and at the end of our PHP block, we will create a new statement to load all of our stories. Story list statement is now pointed at what we call a result object that we can use to cycle through the results. Go to the bottom of the form and add a new PHP block. We are going to loop over each result in story list statement. In the middle of the for each, we need to add a div for each story. It will include a link that we will use to open the story, and show the date and time the story was created as well. You'll see a new function here called date. This function can be used to apply formatting to a timestamp. I highly recommend checking out the documentation for this function later. You'll also notice a story ID parameter in the URL we added. Now we should add one more link to create a new story at the top of the form. Here, we will use another URL parameter, new story. Let's make use of these 2 new parameters. Let's add some logic at the top of the page after our session start. First, we will check to see if new story exists. Notice I am using the get parameter. This holds the values of all of our query string parameters in the URL. If new story exists, we should clear out the session. Then, we want to use PHP's header function to redirect the user back to this page to start a new story. The header function is used to send any HTTP header back to the user's browser. The location header will redirect the user back to the page given. Finally, we will call exit to let PHP know we are done processing this page. Now we add one more check that will manually set the story in the session if the story ID parameter exists in the URL. We will add an else if check for this, then we can set the session story to that value. Great job! we should go check out our index page, localhost port 8080/madlib/index.php. Let's see if we can create a new story. Click on the Create link. It looks like it successfully cleared out our words. What happens if we click once again on our first story? You'll see that our original story repopulates the form. Great work! In this video, we were able to successfully integrate our forms with the database. In the next video, we are going to see how we can use classes and objects in PHP to make this code a little bit cleaner. Welcome to the last video of this section. We have written a decent amount of code now. However, you may notice that we have some duplicated code across our project. We are going to learn how we can use PHP's object-oriented features to eliminate some of this duplication. In this video, we will identify some code that would be a good candidate for moving into a class. Then we will create the corresponding classes, and finally we will refactor our code to use our new classes. Let's begin by opening both story.php and index.php side by side. The first thing we want to look for is duplicate code that exists in multiple areas of the site. There are three different things we do in both index.php and story.php. In both files, we open a session, connect to PDO, and then check to make sure we have a story set up in our session. All three of these functions are really aspects of the application and things we will probably need to do frequently. Let's go ahead and create a class to put these in. Right-click on the madlib directory and choose New PHP Class. We'll give it the name Application and we'll put it in the madlib namespace. The remaining fields are fine as is. Go ahead and click OK. Your new file is created. You will see in this file that the namespace has been set and your class is defined. It is a best practice in PHP to add comments to both classes and methods to describe what they do and how they should be used. We should add a descriptive comment to our class. These comments start with a / followed by 2 stars. Hit Enter and PHP Storm will fill out the rest of the comment. Now we can just describe the purpose of our class. Let's start adding some methods. First, we'll take care of the session. Create a new function called initializeApplication. We are going to make it a public method. That means that it can be called from anywhere. We don't need any parameters, so the parameter list will stay empty. In the body of the method, we can call session start. We should also add our method comment just like we did to the class. Now we can add a method that handles returning a database connection. We don't need to establish any more than a single connection. So first, we are going to add a property to our class that can hold the connection. We'll call that property PDO. We'll make it private so nobody can access it outside of our class. It is a good practice to limit visibility to only where it is needed. This results in more maintainable code. Again, we will comment the purpose of our property. This time our comment has a line at the end with an @var followed by a /PDO. This is called an annotation. It is used to provide additional information about whatever you are commenting. In this case, it is telling us the type of this variable. The /PDO means it is the PDO class found in the root namespace. If the / did not exist, it would look for a PDO class in our current namespace, which is madlib. Now we can add a getDatabase method. Again, it will not take any parameters. In the method, we will check to see if the PDO property is empty. Using the this variable, you can reference any property or method on the current object. If it is empty, we will set it to a new PDO object and set its error mode. Then we can simply return the PDO property. In our comment, you'll see another new annotation, @returns. This indicates the type of value returned from this method. We're going to add 2 more methods, one to get the story and one to set the story. First, let's add the method to set the story. We will call it setCurrentStory. All this method will do is set the story session variable to whatever value you pass to it. This means we need it to accept a parameter. We will call the parameter storyID. It'd be nice to be able to use this method when we need to clear the story as well. We can make it so that if you don't pass a parameter, it will set storyID to null using a default value for the parameter. Now the body of the method simply sets the value for session story. You'll see another new annotation called @param. This annotation can be used to document the type of parameters. The first field is your type. The second field is the name of the parameter. It should match the name in code. Now we can add our method to get the current story. It will check to see if session story exists. If it does not, it will execute a query. Notice how we use both getDatabase and setCurrentStory in this method. We then return the value of session story. Let's integrate our new class. We'll start with story.php since it is already open on the right. Start at the top of the file by instantiating our class. This is done just like we did with the PDO class using the new operator. You'll see autocomplete pop up as you type the class name. Choose the application class and PHP Storm will do the rest. You'll notice that both the namespace and class name were added. When referencing the class, you must either use the fully qualified class name as you see here, or you can add a use statement to shorten the name. Try removing the madlib so that all you have left is just application. You'll see PHP Storm highlight the class, now indicating that it can't find the class. Now, on the line above, add a use keyword followed by /madlib/application. You'll see the error go away. Use statements are very useful when you're using the same class multiple times to keep your code concise. By default, use will shorten the name to just the class name. If you are using two classes with the same name but in different namespaces, you can use an alias by following the class name with as, and then you can call it whatever you like. Now we can replace session start with a call to initialize application. Then we can replace the database connection code with getDatabase. Finally, let's get rid of the code setting up the story with a call to getCurrentStory, and then we can replace all of the references to session story with our new story ID variable. Now we can do the same thing in index.php. In index.php, we also need to make a couple of extra calls to set story where we clear the story ID and set it to the value from the URL. We should be all done now. Go to the browser and take a look at localhost port 8080 madlib/index.php. Uh-oh, what happened here? The problem is that PHP doesn't know where to find our application class. You need to tell each file where to load it from. In index.php, you can do this using the require or require once statement. The difference between these two statements is that require will always attempt to load the file, where require once will only load it if it hasn't already been loaded. The parameter to both of these statements is the path to the file. Require is set up to scan multiple directories that are specified in your PHP settings include path. I recommend you search the PHP docs for include path to learn more. Something we can do so we don't need to worry about include paths is use the dir constant to build an absolute path to the file. Now go refresh the browser and the page should show up again. Let's add the same require to story.php and we'll be all done. So now we have a fully working website complete with our own application class. In this video, we have used some of PHP's object-oriented features to improve the functionality of our application. In this section, we have gone over building a simple form and a page to process its results. We integrated session handling into our site. We learned how to navigate through PHP's web of documentation to find whatever functionality you may need. We integrated with a SQLite database for more persistent storage. And finally, we took a look at some of the basic object-oriented features that PHP has to offer. In the next section, we are going to jump into our first big project, a URL shortener. Hello! We are now in the third section, turning long URLs into short ones. In the previous section, we learned about general features of PHP while implementing a basic form. In this section, we will create our first real PHP project, a URL shortener similar to a service like Bitly. In the process, we will learn how to structure our project. We will work through real-life examples of the MVC pattern. Then, using concepts from domain-driven design, we will discover some techniques to secure and validate information being submitted by a user and learn how to encapsulate storage of that information. Finally, we will tie it all together with some tips and tricks for implementing a front controller leveraging PHP and Nginx. In this video, we will focus on setting up our project. First, we will create the project and basic structure in PHP Storm. Then we will enable Composer. Finally, we will configure our VM and host to allow us to view the project in our browser. First, why don't we start out by creating a new project in PHP Storm? We can choose PHP Empty Project. For the location, let's create a new directory under our PHP Projects directory called url.dev. Be sure to select PHP 7 for our language level. Now, click on Create. We now have a project. Let's create a few directories to get our project layout started. The first directory is Source. Right-click on URL dev and choose New Directory. This directory is going to hold the classes that we create for our project, so we want to mark it as a source's root folder. Right-click on Source, choose Mark As, and then select the source's root option. The next directory we want to create is the www directory. The www directory will be the document root of our project for the web server. This means any files in this folder will be accessible from the browser. To indicate this, we can mark the directory as resource root. Now, we need to create a home page for our project. Right-click on the www directory and choose New PHP file. Let's name it Index. The .php will be added for us. Now, in Index, we should just add a basic HTML template that we can use for our project. I'll just paste in the HTML for now. We'll be moving this to a new file soon. Now, we should set up Composer. It is a great tool that can handle dependency management. We don't have dependencies yet, but this will allow us to easily add them when we do. To use Composer, we need to open the Terminal tab in PHP Storm. Make sure your VM is running by typing vagrant up and then log into your VM using vagrant SSH. Now, change directories to /var/www/url.dev and run Composer init. Composer will walk you through a series of questions to help you create your project. The package name is used to help identify your project from all of the other projects. Vendor should be something unique to you or your company, and the name can be something specific to your project. We will use php-projects/url.dev. You can put anything you would like into the description. It should indicate what the purpose or use of the project is. We can just say that this is a simple URL shortener. Next, we need to put our name. Put in your name followed by your email address in angled brackets. The minimum stability section is used to determine if you are okay with beta or development libraries being used in your project. We will use stable for now to indicate that we want production-ready libraries. Next, we need to set our project type. The most common types are library, the default, and project. A library is something that other projects would use and is not standalone, so we want to use project. The next section is for license. You can choose any license you want. We'll just use MIT. Next, you would normally declare your dependencies. We aren't going to have any dependencies quite yet, so we will just say no. We will touch on the difference between dev and regular dependencies in the next section. For now, we can again just say no. Now we can confirm our settings and generate our Composer file. Go ahead and type yes, then hit enter. Now, you should see a composer.json file in our project. This is the file that holds all of your Composer configurations. Composer is now initialized. Good job. Composer is a powerful tool that we will continue to touch on, but if you would like to look at Composer in more depth, then you can find out more from their site, getcomposer.org. Now, we need to make our new project accessible in the browser. To do that, we need to make some changes to PuffPit. Let's use PHP Storm. Go to File, Open Directory. Now, change directories to the PuffPit directory and select OK. We are only going to be in this directory for a short period of time, so go ahead and choose to open in a new window. At the root of the project is a config.yaml file. Let's open it. Scroll down and you'll see a section for Nginx that contains a single virtual host. We want to duplicate the virtual host as a template for our new host. The virtual host as well as the location blocks have an identifier that must be unique. We can make a new identifier for all of these just by adding one to the end of each of the three identifiers. Now, we can set the server name to url.dev. Then we need to change the document root. We want it to point to the www folder that we created earlier. Remember, our files in the VM are all located in /var/www. That should be it for changes. Now go back to your other PHP Storm window. We need to create a new session on our host in the terminal. You can do that by right-clicking inside the terminal window and choosing New Session. Now, you can run Vagrant Provision. Vagrant Provision has created all of the configurations necessary on the VM. Now, we just need our host computer to understand where the domain goes. Since we don't have our own DNS server, we have to use our host file to point the domain url.dev at our VM. On Mac and Linux machines, we can just edit as root the /etc/hosts file. On Windows, the file is at c/windows/system32/drivers/etc/hosts. In order to edit the file, you may have to create a copy elsewhere, like your desktop, and edit it from there. Then copy the file back using an administrator password. First, add in the IP address of our VM, 192.168.56.101, followed by the domain you want to point it at. Save the file and we are done. If you're curious how to determine the IP address, it is set in our puffbit config. But you can also run ifconfig on the VM and look for the IP address of the ETH1 adapter. It should be the same on both of our VMs. Go to url.dev in your browser and you should see our HTML file. Well done! In this video, we managed to set up our new URL shortener project. In the next video, we will use the MVC pattern to add some functionality to our project. Welcome to the second video of the section. In the previous video, we set up our project. However, we have not established a good pattern to use in adding code to the site. In this video, we are going to look at the Model View Controller or MVC pattern. We'll see how we can use a bootstrap file along with autoloader to simplify implementation of the pattern, and then see how we can apply MVC to our site by using all three of those components to build a functioning form with a confirmation page. Up to this point, we have been using the require expression to load files containing PHP classes. PHP has an ability called autoloading that will allow you to automatically require files based on the name of the class requested. Composer makes this very simple to configure and can save you a measurable amount of code. Open composer.json. At the bottom, we are going to add an autoload section that contains a key called PSR-4. PSR-4 is an autoloading scheme created by a group called the PHP Framework Interoperability Group. The standard is that you can declare a given directory to contain code for a given namespace. Here we are saying that Composer should look in the source directory for any classes or sub-namespaces that start with URL shortener. If a full class name is URL shortener/file, then the class will be found in source/file.php. If the full class name is URL shortener/subnamespace/file, then the class will be found in source/subnamespace/file.php. Now with that change, we can run composer install. This will fetch and install any dependencies which we don't have, as well as rebuild an autoloader based on the configuration provided. Check your project now and you'll notice a new directory called vendor. This is where both our dependencies as well as our autoloader will be placed. You'll notice the autoload.php file. As long as this file is loaded via require, we shouldn't have to directly require any of our other class files. Since the vendor is going to contain some code, we should mark it as a source's root. Now we need a way to load our autoloader. It is common to have a single config or bootstrap file to set up globally necessary aspects of a project, such as autoloaders. We will create our bootstrap.php file in the source folder. All we need here is a require statement loading the autoload.php file. We will use the dir constant to make sure we get the correct file. Great work! Our autoloader is set up. We are going to implement this project using the Model View Controller pattern. In this pattern, you have three basic sets of classes or files. You have the model, which creates a class representation of the business domain you are working with. You have views, which provide a way to visually represent your model, and you have controllers, which allow you to connect the appropriate view to the appropriate part of the model, and also allows for manipulation of the model, commonly driven by the view. Let's start with our view. We will create another directory in the root of our project called views. We should mark this directory as a source's root, as our views will all be PHP files. Conveniently, our front page view is exactly what we already have in index.php in the www folder. Click on that file and drag it into the Views folder. A dialog will appear to help ensure that you aren't breaking any existing links to that file. Go ahead and click OK. We can now work on our controller. Create a new class in the source directory by right-clicking on the directory and clicking New PHP class. We will call the class URL Controller. We need to also make sure that the namespace is URL Shortener so that Composer's autoloader can find it. This will produce a template containing the namespace and class and some boilerplate comments. I'm going to paste in the contents of our controller. The important piece here is the public getIndex method. You'll notice it is simply including the contents of our view. Having to repeatedly type out the full path for our view files can get a little tedious. We can improve this using our bootstrap.php file. Let's create a new constant called config_views_dir that points to our views directory. This way, we don't have to constantly make sure we are choosing the right relative path to a view from within our project. Just replace the dir constant with the relative path with our new config views dir constant. Much better. Now we need an endpoint that loads the appropriate controller so we can see all of this in our browser. Create a new index.php file in the www folder. In this file, we need to make sure we include the bootstrap, otherwise we don't get our autoloader or views constant we just created. Then, we just need to create an instance of our URL controller class and call our new getIndex method. Now, you can go to your browser and view url.dev. It works. Great job! Now that we have a front page leveraging the MVC pattern, we should add the ability to process that form. So far, we haven't needed any classes in our model. When we submit the form, however, we need to create a new shortened URL that understands which URL it should redirect to. Create a new class called URL entity in our source folder. I'm going to paste the contents of this file and we can step through each piece. The first thing to take note of are the two private properties, target URL and shortened URL. This is really the only data that we need to track for right now. In our constructor, we are going to accept a target URL. This will be a string with the full path to the URL we are shortening. Then, we will set the shortened URL to a random string created by generateRandomToken. The generateRandomToken method is a little bit complicated, but still not too bad. Basically, it is creating an array of qualified characters using numbers, lowercase letters, and uppercase letters. Then, it is randomly choosing one of those characters 8 times to formulate our URL. Feel free to look up any of these functions in the PHP docs if you are not familiar with them. Finally, we have a couple of methods to return the contents of our properties. These are commonly called getters. It is worth noting that there is no way to set these properties once the object is created. This is called an immutable object. This is an object-oriented concept that helps ensure that the state of our objects is predictable. It can be very useful in keeping your code free of potential side effects. I know whenever I pass this object to another method, I should be able to assume that the object won't be modified. Now we need to add a new method to our controller to handle the form submission. We will add a postIndex method. For now, we are going to store our data in the session just for testing purposes, so we need to call session_start. Then, we will create a new URL entity using the URL posted in from the form. We'll save that to the session so we can read it later. Then we need to encode the shortened URL so that we can safely pass it as a query string parameter so the shortened.php script knows which URL to show. Now we need to update our front page endpoint so that it can call our new controller method. Open index.php. Now we want to check to see if the request method was post. If so, we will call postIndex. Otherwise, we'll call getIndex. Next, we need to create the shortened.php file we are redirecting to. Create shortened.php in the www directory. We will include our bootstrap, instantiate the controller, but now we will call a new method, getShortenedURL. Use Alt-Enter to add this new method to our controller. On this page, we will be reading the URL from the session, so we need a session start call. Then, we will set URL variable to the URL from the session. This will be read from the shorten.php view we include next. To wrap things up, we just need to create our view. Create shorten.php in the Views folder. This view will show us which URL we are looking at and where it will redirect to. It also includes a form to create another redirect. You'll notice where it is reading data from our model using the URL variable we set in the controller. We are able to access this variable because we initialized it in getShortenedURL, where we include this file. Had we not initialized the variable in getShortenedURL, we would get an error about calling a method on an undefined variable. Now go to url.dev in the browser. Enter in a URL and click Shorten. Now you can see our new confirmation page. We have successfully used the MVC pattern to create a functioning form and confirmation screen for our application. In the next video, we will make some changes to clean up the processing of our form by securing and validating the data. Welcome to securing and validating our data. In the last video, we implemented the ability to submit URLs to the system. However, right now we are accepting anything in that form. You could submit valid URLs, invalid URLs, or even blank strings. In this video, we are going to implement validation to help ensure that we only store information for valid URLs. We will see how we can add validation to our model through the entity. We will see how we can leverage that validation with our controller. We will also add some error messaging throughout the application so that the user knows if they did something wrong. Let's start by seeing how the system currently works without validation. Go to url.dev in your browser and just simply hit the Submit button. You'll see that the system has generated a shortened URL for your blank string. This is not very useful. It could cause a decent amount of confusion for users as well. The same problem also exists if you type in a poorly formatted URL. We need to improve this experience and protect the validity of the data that we store. When implementing validation of data that you are placing in entities, it is usually a good idea to put the logic doing the validation on that entity. The business logic that controls the validity is an inherent aspect of the entity. Keeping them together makes it easy to find, reuse, and if necessary, expand. Go to urlentity.php. We're going to add a new isValid method. This method has a small amount of complexity, so let's go over it section by section. The first thing we do is use PHP's built-in filter extension to ensure that the value is a valid URL. If the URL is valid, we are going to use parseURL to get the scheme of the URL. This is the string that appears before the first semicolon. If you look at the documentation in PHP for URL validation filter, you'll discover that it accepts any scheme. While this could be good for some purposes, we really want to make sure that the link is either an HTTP or HTTPS link. If this is the case, we return true from this method. If the URL is not a valid URL or it does not have an appropriate scheme, we return false. Now we need to make some changes to our controller to check for this validation. Once we create the URL entity, we can use an if statement to check the result of isValid. If it is true, we continue on as before. Otherwise, we should set an error message and redisplay the index view. We do need to make some changes to the index view to make sure that the user understands what just happened. Let's add a new block just after the form to display our error message. This is an alternative if statement syntax for PHP that generally looks a little bit better when dealing with pure PHP templates. You'll notice I am using the null coalesce operator on error message. Remember, this template is used for the GET request too, so we can't count on this variable being set. If it is not set, we can assume that it is false. We should also add a default value to the URL field. This will help the user verify what the potential problem is. Again, we need to use isSet just in case this is the first request where the URL object doesn't exist. Now, go to url.dev. This time, try submitting some bad data, or you could use a blank string again. You'll see our error message and whatever data you entered is persisting. Awesome work. Go ahead and give it a valid URL and submit. Now we are going to go over the second piece of validation. We need to make sure if an object is requested that we have it. Change the URL query string parameter to bad URL or any other identifier that doesn't exist. Now you see errors. Let's investigate these errors. If you look at line 46 where the error is, you will see that it is throwing the notice because when it looks for the key we passed, it can't find it in the session. This then causes the URL variable to be empty, which is what results in the remaining errors. We can fix this by doing additional isSet and validation checks. First, use isSet to check to make sure that our URL is set in the session. Then we can use the instance of keyword to make sure that the value returned from the session is a URL entity object. Then we can use the isValid method to also make sure it is a valid URL. If so, we will display the template. Otherwise, we are going to use the header function to let the client know that we could not find what they were looking for by sending a 404 HTTP status code. Then we will display a new 404 template. Now we need to create the 404 template in the views directory. We will just display a simple message letting the user know we couldn't find what they were looking for. Go back and refresh our error-filled page and you'll see our new 404 page appear. Good job! In this video, we saw how we could add the concept of validation to our models and then integrate it into our views and controllers. In the next video, we are going to learn how we can add database persistence to our model. Welcome to the fourth video of this section. In the previous video, we added some important code to make sure that we only accepted valid data. However, we are still only storing that data in the session. In this video, we are going to start saving and retrieving data from the database. We will create a new SQLite database with a table for our URLs. We will introduce the concept of a repository to our model. We will create a way to share a database connection throughout our application. Then we will tie everything together in our controllers and our Bootstrap to start leveraging the database. Let's get started by creating our database. First, we need a directory to put our database in. We will be using SQLite again, which as you remember is controlled by a file on the server. We'll create a new directory called data for this file. Right-click on the data directory and choose New Data Source. We will call our new data file url-shortener.sqlite. Click OK. The Data Sources screen now pops up with everything pre-filled. We really just need to change the name. It can be anything, but I'd prefer it to be named the same as the file. Click OK. Our data source is created. Now in the database panel on the right side of the screen, you can select our new data source and then click on the plus sign above it to create a new table. We'll call our table URLs. We are going to need 3 columns. The first will be called shortened URL. Since this needs to be a unique value, we can use it as our primary key. It will be how we look up already saved URLs. We'll make it a varchar and make sure it cannot be null. The second column is target URL. This will also be a varchar, and again, it cannot really be null. The third column is timestamp. It will be an int and it will never be null. Click Execute to build the table. The table may not show right away in the database pane, and if it doesn't, just click the Synchronize button in the database toolbar. Now you should see the table in the database pane. A common pattern to use in storing and retrieving objects in your model from databases is the repository pattern. The purpose of the repository is to provide your application with an interface that it can use to add, remove, update, or read entities from without having any understanding of the underlying data store. The repository can be considered as a part of the model layer. As such, it shouldn't interact directly with the view, nor should it depend on the controller. Its only dependency will normally be on entities in your model, as well as whatever infrastructure layer classes necessary to interact with your data store, such as PDO. Our repository class will be called URL repository. I'll paste in the code for the class. Our repository will use PDO to connect to our SQLite database. To enable this, we should have a PDO property, and for now we will set it from the constructor. The getURL method issues a prepared statement to retrieve a URL row by the shortened URL value. If a row is returned from the database, we pass that to a new static method on the URL entity class called createFromArray. That will take the data from the array and generate a URL entity object. The addURL method builds a query that inserts values into our various rows. It then prepares and executes the statement. It is very simple. You'll notice that PHP Storm has highlighted a few issues. Let's quickly fix those. Click on one of the highlighted queries and then use Alt-Enter to bring up the quick fixes. It is wanting us to set a SQL dialect. This lets PHP Storm find potential syntax errors in our query. Go to the top folder and change this dialect to SQLite. Click OK. Then click on the Create from Array method and use Alt-Enter again. Select Add Method. This creates our method in URL entity. We want our Create from Array method to construct a new URL entity object. Then, we also need to manually set the shortened URL to the value from the database. Then we can return the object. What we have created is essentially a named constructor. It serves exactly the same purpose as a constructor, but it has a name more indicative of its exact purpose. Let's move the method to be closer to the actual constructor. We should also refactor our default constructor a little bit so that we don't always have to spend cycles generating a random shortened URL. We can add a second parameter for the shortened URL and default it to null. If shortened URL is null, we use the existing logic. Otherwise, we pass the value through to the shortened URL property. Now we can adjust our create from array method to use the second parameter instead. We need a way to now centralize our database connection. This will make connecting to the database easier to manage and will give us an easy path to configuring that connection in our Bootstrap. Create a new database service class. This will be a somewhat lengthy class, so I'm going to paste the contents again. Our constructor is going to take a PDO object and store it as a property. We will also provide a getter for PDO. Then you'll notice some static properties. We want to have a way to make sure the various methods in our code are all operating on the same instance of this connection. The static instance property serves this purpose. It will hold the shared database service object for our application. Default PDO parameters will contain the constructor parameters that we use to create the PDO object for our shared instance. It is accompanied by a setter. The getInstance method is what helps us ensure that every method uses the same service object. It will return the instance property when set. If it isn't set, it will create a new database service using a PDO instance generated using default PDO parameters. You'll notice in the constructor of PDO there are 3 dots followed by the default PDO parameters property. This is PHP 5.6's argument unpacking operator. When used in a function call, it results in the following argument being expanded into multiple parameters. So, if the value of default PDO parameters was an array containing the numbers 10 and 20, then the equivalent call would be against the PDO constructor setting parameter 1 to 10 and parameter 2 to 20. Once the PDO object is created, we are setting its error mode to exception mode, and setting the instance property to our new data service object. You'll notice that we will only ever run the code within that if statement once. Now we can make some changes to our URL repository. Use the database service to get its PDO object. We will change the constructor to no longer accept a parameter. Instead, we will directly call database service getInstance and use its getPDO method. Normally I would not recommend doing this kind of work in the constructor, as it will cause some issues with flexibility. We'll discuss this more in our next section and show a better way to do things. This does keep our example a little bit simpler for now though. Now in our URL controller, we can make use of the repository. We want to use the repository now instead of the session to maintain our data. In post-index, we can simply replace the line that set the session key to instead create a repository and call add URL. In getShortenedURL, we can consolidate our checks. We no longer need to check the session key. Instead, we just create a new repository and try to retrieve the URL. If a URL is returned and it is valid, we can load the shortened PHP template. Otherwise, we send the user to our 404 template. Now, we need to configure our database connection. Open up bootstrap.php. We are going to use the setDefaultPDOParameters method on database service to set the path to our SQLite file. Now head to url.dev and enter a valid URL. We are seeing a populated confirmation screen. This is a good sign. Go back to PHP Storm and double-click on the URL table in the database pane. you'll see that we have our data listed. Fantastic work. In this video, we updated our application so that we can store our URL data in the database. In the next video, we are going to add the last missing piece to our application. We are going to allow our shortened URLs to redirect the user to the appropriate location. Welcome to the Redirecting Our Users video. Our URL shortener is coming along quite nicely. However, it is still missing the most important piece, redirecting our shortened URLs. We are going to implement the redirection functionality now using the various classes we now have in place. In this video, we are going to use our repository to search through the database for a list of redirects. We'll add a new action to our controller to handle the redirect. We'll use some advanced logic to determine in our endpoint if we need a redirect or not. Then we will see how we can maintain some statistics on the number of times a shortened URL has been used. We don't really have a great way right now to get an already established shortened URL. So let's add a list of the most recent URLs to our homepage. To do this, we need a new method in our repository that can look up the most recent URLs. We'll call our new method getLatestURLs. It'll accept a number as a parameter that will be the limit of URLs that it will display. We'll simply order our SQL result by the timestamp in descending order. After executing, we'll loop through the results and add all of the returned URLs to an array. Then we can simply return that array. Now we need to update our controller and send this data to one of our views. Let's change the getIndex method to instantiate the repository and set the most recent URLs variable with the content of our URLs. Now we need to update the view. Go to the index.php view. After the form tag, let's add a new block of code. We need an if statement to ensure that this block only shows up if most recent URLs is set, is an array, and isn't empty. Then we can loop through the URLs and display a link to the URL as well as that URL's confirmation or stats page. Now go to url.dev in your browser. You should see a list of our most recent URLs. If you don't, then go ahead and add another just in case your database is empty. Now we need to handle the redirect. Go to urlcontroller.php. We are going to add a new method called redirectURL to handle the redirect. We will pass the value that we want to redirect from as the shortened URL parameter. In this method, we will create a new repository and attempt to retrieve the URL. Then, we will check to make sure the URL exists and is valid. If it is, then we will redirect the user to their target URL. Otherwise, we will display a 404 page. Now we need to update our endpoint to use this new controller action. Go to the index.php endpoint in the www directory. If the request method is not post, we are going to need to execute more logic. Nginx is configured by default on our VM via puffpit to pass any unhandled URLs to our /index.php page. The requested URL will be set to the server request URI variable. We can parse this URL and then use the path of the URL to see what exactly we are requesting. We are using regular expressions to test and see if the path contains a single directory. If it is just /, it will fail this regular expression. It then assumes that the path provided is our shortened URL and passes that along to our redirect URL method. If we detect just a / or multiple paths, we will continue executing as normal. Now we can give it a try. Go to url.dev and click on one of the links. You'll see that you've been redirected. It works. Now we should see if we can collect some statistics on how many people have clicked our link. To do this, we will need a new column in our database table. Go to the Databases pane. Right-click on the URL table and select Modify Table. We are going to add a new column called Redirects. It will be an int that defaults to 0 and cannot be null. Click on Execute. Synchronize the data source, and you should now see our new column. Now let's add this new piece of data to our entity. Open up urlentity.php. We will add a new property called redirect count. We will set the redirect count to 0 in the default constructor since new URLs will never have been redirected. In the createFromArray constructor, we will set the redirect count from the redirects index in the array. Finally, we will add a getter for this value. Now, we need a way to update this value from the repository. Go to URL repository.php. We will add a new method called incrementRedirects. It will accept a URL entity as its parameter. It will then issue an update to the URL table to increment the redirects column by 1, matching on the shortened URL column. We could always run an update using an incremented value in the URL entity. The reason we are not doing that is that if two different requests fired at the same time, each one needing to increment, if they started with the same base value, then you would lose one of the increments. When you update via incrementing by 1 in the database, these operations become atomic, and you can guarantee that both increments take place. Now, we can leverage our new repository method in the controller. Open up urlcontroller.php. In the redirect URL method, we can now call incrementRedirects prior to issuing the location header. Let's add a line to our confirmation page to show the number of redirects. Open up view/shortened.php. Underneath the first p tag, we will add another paragraph that contains the redirect count. We should be in business now. Go to url.dev in your browser. Command or Control-click on the URL. Now, click on the stats link. You'll see that our redirect count has been implemented. In this video, we have successfully implemented our redirector and even added a little bit of stats tracking. In this section, we have gone through the entire process of creating a URL shortener from scratch. We saw how we can set up the file structure and foundation for a fresh project. We learned how to leverage MVC to structure the classes in our project. We augmented models with validation. We migrated our data out of sessions and into a SQLite database using repositories. Then, we learned how we can implement a redirect from our controller while keeping statistics of how many times we did so. In the next section, we are going to learn how we can create an automated test suite to ensure that what we have implemented works properly. Welcome to the fourth section of automated testing of our shortener. In this section, we will learn how we can use unit tests to improve the quality of our shortener as well as any other PHP projects we are a part of. We will cover how to install PHP Unit and the basic structure of a test. Then, we will look at some more advanced testing concepts like mock objects, database testing, and functional testing using Selenium. In this video, we will learn about PHP Unit, a popular unit testing framework for PHP. First, we will install PHP Unit using Composer. Then, we will configure our project to use PHP Unit. Finally, we will add a test and learn how to use PHP Unit to run that test. Let's get started. We are going to use Composer to install PHP Unit. Make sure that you are on your VM in the /var/www/url.dev directory. Then, type composer require --dev. This composer command is used to install dependencies in your application. The --dev means that it is a development dependency. It isn't required in production, but is necessary to build or maintain your project. Now, it is going to ask you to search for a project. Enter PHP Unit. This will result in a list of matching package names. If you aren't sure which one is correct, you can use the Packagist website at packagist.org. Packagist is the default PHP repository for Composer. Enter PHP Unit in the search, and you'll see the same packages, but you'll be able to get more information to choose the proper one. We want PHP Unit/PHP Unit, so go ahead and enter 0. Now, it asks us for a version. If you do not know which version you want, you can just hit enter and Composer will choose the latest stable version for you. You can see here that Composer is going to install 5.4. The caret in front means that when you use Composer Update to update your packages, Composer will always choose the latest version of 5.4, be it 5.4.1, 5.4.2, etc. You can read more about how Composer handles versioning in their documentation. We are done selecting packages, so hit enter. You'll see Composer installing several packages. Composer is able to understand all of the dependencies of PHP Unit, so it is automatically installing those for you as well. Now that installation is complete, let's see what it did. Open composer.json and you'll see a new section, require-dev, with our PHP Unit dependency. Then, if you look in the vendor directory, you will see that is where all of the packages that Composer installed are located. Now that PHP Unit is installed, let's configure it. When PHP Unit is executed by default, it will look for a file in the current directory called phpunit.xml. PHP Unit has a number of command line parameters that you can see by running phpunit-help. This configuration file allows you to set defaults for all of those parameters and also gives you a few extra options. Our configuration is very basic. You'll notice two attributes in the root PHP Unit element. Bootstrap specifies a bootstrap file for our tests. Similar to the application's bootstrap.php, this file is ran prior to any tests and can be used to set up autoloaders or any other dependencies your test suite has. The second attribute is colors. It just makes the output of PHP Unit a little easier to read by displaying a green line when tests pass and a red line when they fail. The test suites element is where all of the test suites can be defined. We just have a single test suite named URL shortener unit tests. We are going to place those tests in the tests directory. To view all of the other options you can use, go to phpunit.de/manual/current/en. The PHP Unit documentation will list out all of the various elements you can use in this file. Now let's take a look at our Bootstrap and a test file. In url.dev, there is a tests directory. Since this contains our tests, it should be marked as a test sources root. In that directory is a test-bootstrap.php file. If you look at that file, you see that it is just requiring our autoloader. If there is other setup necessary for our test suite to run, such as a database connection, it could also be added here. Now, we can take a quick look at our tests file. Open URL entity test.php. This is a PHP Unit test that is testing our URL entity class. Inside, there is a setup method and 4 different test methods, each prefixed with the word test. For now, don't worry too much about the contents of this file. We are going to discuss it more in the next video. Now, go back to the terminal. You can run PHP Unit by executing vendor/bin/PHP Unit in the url.dev directory. You'll see that our test has run successfully. In the full output, you'll notice that each test is represented by a single period, letting you know that the test has passed. Great job! In this video, we installed PHP Unit, configured it to work in our project, added a test case, and learned how to run the test suite. In the next video, we will dive a little bit deeper in how our test case works and what it is actually doing. Welcome to the second video of the section. In the previous video, we installed PHP Unit and set up our first unit test. However, if you are new to unit testing or PHP Unit, then what the test was doing probably didn't make much sense. In this video, we are going to dive a little bit deeper into how PHP Unit runs tests and how you should set up your test cases using our existing example. Then, we are going to walk through setting up a new test. Finally, we will see through our new test how we can find bugs in our software. Why don't we take another look at URL entity test.php. Before we talk about the code inside, let's talk about the file name and location. When you are creating a unit test, you are wanting to focus on encapsulated pieces of code. The easiest place to start usually is a class. This has led to a very common practice of laying out your testing directory and file structure in a way that mimics your production code structure. So a good starting point would be to duplicate each PHP class file and source into our test directory. It is a default standard in PHP Unit that all of your test case classes will end with the word test. Because of this, the one change we do need to make to the testing directory structure is modifying the file names so they match the names of the classes inside. So instead of URL entity.php, we have URL entity test.php. If we had a test case for our controller, it would be called URL controller test.php. This type of structure is not strictly required, but it is a great place to start. Once you build a large test suite, you may want to use multiple test cases for a given class. In the future, we could have something like URL entity creation test and URL entity validation test. Now, we should take a look at the file itself. We are using the same namespace for our test as we use for the classes we are testing. This is not required, but it does make life a little easier as it reduces the number of use statements. We are extending the class PHP Unit Framework Test Case. This is the base test case for all tests in PHP Unit. It defines the structure required by your tests as well as provides a large number of assertions you can use to make sure your test is running properly. PHP Unit executes in a very well-defined manner. For every test in a test case, it will follow 4 steps. First, a new instance of your test case is created. This is important to mention because it means you can't share data between tests using class properties. This is largely by design as you want to keep your tests from influencing each other. This influence could complicate the running of tests and how you interpret test failure. On your new test case instance, the setup method will be called. The method should be used to set up what is referred to as a fixture. A fixture is just a known, defined state required for the code you are testing to run properly. You can see in our setup method we are instantiating a new instance of URL entity. Once setup finishes, PHP will invoke your test method. Test methods may also involve some additional setup of your fixture. You can see in test URL entity creation from array that we reset the URL entity to a different value. In general, you use setup for the common or at least the most common parts of the fixture, then you can add or override the test-specific pieces of your fixture as the first step of your test method. Once the fixture in your test is complete, you can exercise your code, then you can use PHP Unit's assertions to validate your code. Assertions are key to ensuring your code did what it was supposed to. PHP Unit comes with several built-in assertions. You can view a list of available assertions in PHP Unit's documentation in the Assertions appendix. The typical parameter list of an assertion usually starts with an expected value, followed by an actual value. Then, the last parameter is usually an optional message parameter. This message parameter can be used to provide further clarification when a test fails. You can see a few different assertions in test URL entity creation with generated URL. I am asserting that the value for target URL equals google.com. The value for redirect count is 0. Then, since I can't predict the generated URLs, I am just making sure that the generated value matches an expected pattern using an assertion for regular expressions. Once PHP Unit is done calling your test method, it will call teardown. Teardown traditionally is used to clean up any fixtures you needed to create in setup. If your fixture is just a bunch of variables, PHP will take care of this for you. This is why our test case doesn't have this method. In more complex tests, if you opened a file handle or maybe a database connection in setup, then it would be appropriate to define a teardown method to clean up those resources. Alright, now that we have some of the basics down, let's add another test case. I want to test and make sure that we aren't allowing invalid URL schemes through. We are only supposed to accept HTTP or HTTPS URLs. So we'll create a test named test invalid URL scheme. I'll need to define a new URL entity, and I'll set the target URL for that entity to ftp://myftp.com. Now, we just need to assert that the isValid method returns false. I'll add a custom message to indicate that only HTTP or HTTPS schemes are allowed. Now, open up the terminal, and from your url.dev folder, execute vendor/bin/phpunit. Uh-oh, we have a failure. We will need to investigate what happened. The test itself was pretty simple, so take a look at the isValid method in URL entity. If you take a close look at where we are checking our two protocols, you can probably spot the mistake. We are using the assignment operator instead of the equality operator. I love it when unit tests are able to catch silly mistakes like that. Let's fix that real quick and rerun our tests. There we go. Now our tests pass. Great job. In this video, we have learned more about the structure of unit tests. In the next video, we are going to look at how we can test more complicated classes that have dependencies on other objects. Welcome to the third video in this section, using mock objects in a test. In the previous video, we learned the basic structure of a unit test and added our own test to URL entity test. In this video, we are going to learn how we can use mock objects. We will see why it is hard to test our controller without mocks. Then, we will quickly review Fake, a PHP mocking framework. Finally, we will learn how we can refactor our code to allow us to use Fake to successfully write a test against our controller. Open urlcontroller.php in the source directory and take a look at the getIndex method. It is a fairly simple method, however, there is not really much we can test. It doesn't return a value. This makes it more difficult to test than URL entity was. It does, however, write output to the user, so maybe we can validate that. In urlcontroller.test.php, you can see our setup method. We are instantiating urlcontroller, and then we are setting an expectation in our test. Expectations in PHP Unit are similar to assertions. However, unlike assertions, expectations need to be placed before the code you are testing, as they are expecting a future thing to happen. The expectOutputRegex method allows us to test output from PHP. In our case, we are just going to test that the most recent URL section is showing up in the output. Let's run the test and see what happens. We get a rather cryptic error. We can use the output from PHP Unit to track down the error. It seems to be occurring in databaseservice.php on line 66. Open up databaseservice.php. The code on line 66 is using PHP's argument unpacking feature. The reason why this error is happening is because we haven't specified any default parameters for PDO like what we do in our application bootstrap, and the unpacking operator will not work on a null value. Go back to PHP Unit and look at the stack trace. You can see if you are looking through those files that this code is getting called because we are instantiating URL repository in getIndex. This in turn instantiates a database service, giving us an error. So if we want to write a test for URL controller, does that mean we will also need to set up and run URL repository and database service code? If so, that means we would have to set up a test database. While we will eventually do this anyways, it does seem like it might be a little bit drastic to have to do that right now, when all we want to test is URL controller. Thankfully, we can use a concept common to unit testing called mocking. A mock object will allow us to create a version of any object where we control what it does when it's called. PHP Unit has a built-in mocking library that works okay, but I typically use an alternative called Fake with a PH. It is slightly different than PHP Unit's functionality in that PHP Unit uses expectations for its mocks, as opposed to Fake, which uses an assertion model like what we have already seen from PHP Unit. You can see in the composer.json file that I installed this library using the fake/fake package name. You can install it similarly to how we installed PHP Unit in video 1 of this section. You can learn more about Fake by visiting fake.readthedocs.io. There is a wealth of documentation and features you can read about, many of which we'll be taking advantage of as the series unfolds. Now let's rewrite our getIndex test using Fake. First, let's create a URL repository property. Now in Setup, we are going to use Fake mock to create a mock URL repository and assign it to our property. Fake mock will accept a class name as its first parameter. The easiest way to get a class name is using the class constant that exists on every class. Now the URL repository property contains a mock object. This object will inherit from URL repository, but every method is currently overridden to return null. It is important to note that through this process, URL repository's constructor will not be called. This means that we will no longer try to connect to the database. Now, how do we get our controller using the mock repository instead of creating its own? We need a seam that we can use to inject our repository. The easiest way to do this is through dependency injection. Instead of creating our dependencies directly in our class, we pass them in through either a constructor or another method. The changes for this have already been made, but let's see what they look like. In URL controller, you can see we added a property to hold our repository and added both a constructor and a static method to act as a named constructor. This will keep us from having to repeat ourselves by instantiating a new URL repository every time we create a controller. Then you can see in getIndex where we replaced our direct instantiation of URL repository with our property. Now check out www.index.php and you'll see that we replaced our controller constructor with a create method. We also did the same in shortened.php. Now we'll run the test and see what the output looks like. Oops, looks like there's some more setup we need to do. If you remember from the last section, this constant controls where our views are. This is set up in bootstrap.php. We can fix this error by copying this to test-bootstrap.php. It is not uncommon to have to do similar setup in both your application and test bootstrap file. Let's give the tests another run. We've gotten further, but it looks like our content isn't showing up. Open up view/index.php. If you remember, we are only displaying the header for most recent URLs if we have at least one recent URL. We can go back to our test and add a stub for URL repository to return an array with a URL from getLatestURLs. A stub is a version of a method that does not execute the original value, but returns a value that you control. This is how we get our mock object to return something other than null. To create a stub, call fake_when and pass it the repository. Then, you can reference a property with the name of any method you would like to stub. In this case, we want to stub getLatestURLs. Now, we just specify instructions on what we would like to do when the method is called. In this case, we want to return an array containing a new URL entity. Let's create a new entity and assign it to URL entity. Now, we can use fake's then return method to return an array with URL entity. Great! Now in our test, anytime getLatestURLs is called, this exact array will be returned. While we are at it, let's add a verification using fakeVerify. Verifications are used to ensure that the specific methods of your mock are called with particular parameters. fakeVerify works much like fake_when. We will call fakeVerify and pass our URL repository to it. Now, instead of specifying getLatestURLs as a property, I will call it like a function. In the parameter list, I can specify the exact parameters I would expect to be used when the test runs. For us, that would be 10. It is worth noting two things here. First, I could add this to the fake_when call as well. Then, our stub would only be used when the parameter equals 10. For stubs, however, this is usually unnecessary. The second thing to note is you can use any of PHP Unit's matchers. So instead of specifying 10, I could use greater than or equal to in order to make the test less specific. This is again unnecessary here, but if you can't verify an exact value, it can be very useful. We'll run the test again, and we have another error. It looks like we are attempting to read HTTP host from the server superglobal. The best way to solve this would be to inject this server array into the controller as well. For now, however, we can manually set it in our test. Alright, let's try this test one more time. There we go. Our test runs successfully. Great job. Just to see what would happen if our verification was incorrect, try changing our fakeVerify call to check for the value of 9. Rerun the test. As you can see, fake will alert you that the method you called couldn't be found, and it will even show you some method calls that were close so you can more easily track down your bug. There is a lot more we can do with fake and testing our remaining controller method. If you look at the source files for this video, you'll see the final results of the refactoring of our controller to allow using fake for testing. The process for those refactorings was really the same that you just saw here, but you may be interested in seeing the end result. In this video, we learned about fake and how to use it to create mock objects with PHP Unit. In the next video, we are going to look at how we can use database testing to test our repository. Welcome to the fourth video of the section Testing Database Interaction. In the previous video, we learned how we can more easily test classes with dependencies on other classes. However, how can you test a class that depends on the database? In this video, we are going to learn more about PHP Unit's database extension, DB Unit. Then, we will see how to prepare your project to use the database extension. Finally, we will review how you can use the extension to test methods that read and write data to the database. Let's get started. If you open composer.json, you will see a new dev dependency called PHP Unit/DB Unit. DB Unit is a PHP Unit extension that allows you to treat the state of a database just as you would any other fixture in your test. It has a fair amount of documentation that explains the basics of database testing in the PHP Unit documentation. We will touch on a handful of features, but I encourage you to take some time to check out the documentation and see what all you can do. The core of database testing is provided by the PHP Unit extension's database test case class in PHP Unit. It provides all of the scaffolding necessary to put data into and remove data from a database. As many projects will typically have multiple classes with database interaction, it is very common to create your own extension of this class. This is even recommended by PHP Unit's documentation. We have done this with the database testcase.php file in tests. PHP Unit's database test case leaves two methods that you must override in order to use the database functionality: getConnection and getDataset. You can see here that we have overridden getConnection. In many cases, every test in your application is going to use the same database, so we can consolidate the connection to that server into a single class like you see here. It can be expensive to open new connections to the database, so we are leveraging a static property to continue using the same connection throughout our test suite. If this wasn't a static property, we would open a new connection for every test. Over time, this could take a significant amount of time and could potentially waste resources. The connection returned by our test case needs to adhere to a specific PHP Unit interface. The class default database connection is provided as an adapter for this interface to a PDO class. We are separating out the PDO object from the connection object so that we can reuse the PDO connection in our tests. You'll see it getting used soon. When you are creating a set of database tests, you will need to create a copy of your database that is safe to test against. It is important that this database is separate from your production database, as PHP Unit will regularly wipe out the data in that database to ensure it is in a predictable state. Never use a production database for your tests. In our case, we are using SQLite, so we can simply make a copy of our database. If you look at the data folder, you will see a new test-url-shortener.sqlite database. You may have noticed that we haven't defined a getDataset method. Datasets are typically unique per test case, so we are leaving it out of our abstract class so we can define it separately for each test. This is why we have made our database test case class an abstract class. One last thing we need to do so we can use this class is make sure it can be loaded by our autoloader. This file is in tests, but our autoloader only looks for files in source. Let's fix that. Open composer.json. You can tell Composer to look in multiple directories by converting the value in the PSR4 section to an array. Let's do that and add tests to the end. So now, PHP will first look in source, then it will look in tests for the requested class. That should be everything we need now to start writing unit tests. Great job! There are already tests created for us in URL repository test.php, so let's take a look. As you can see, we are extending our new database test case class. Let's talk for a little bit about the flow of a database test. You likely remember that the overall structure of a regular test consists of setting up your fixture, running your code, verifying the results, and cleaning up your fixture if necessary. Database tests do the same thing. PHP Unit's database test case overrides the setup method to do a few things. First, it will call your class's getConnection to get a connection to your test database. Then, using a dataset defined in getDataset, it will remove all data from the tables defined in your dataset and insert only your data. Then you are free to run your test. If your code changes the database, PHP Unit's database test case provides some added functionality to help verify that the data changed correctly. Let's take a deeper look at this test case. As mentioned before, PHP Unit's database test case provides a specific implementation of setup. It also provides an implementation for teardown. Because of this, you always want to make sure you call the parent setup and teardown if you override them. Otherwise, your fixtures will never run. In setup, we are passing a PDO object now to URL repository. Originally, URL repository would create its own PDO object through the database service. Just like the changes we made to URL controller earlier, we need to make sure we can inject PDO. So we modified the constructor to allow passing in PDO. Now, check out the getDataset method. PHP Unit has many different ways you can provide a dataset. You can use XML, YAML, or CSV files among others. In our case, we are using an array dataset. I encourage you to check out PHP Unit's other options in their documentation. A dataset is just a description of the data you would like to insert into the database. For an array dataset, the first level of the array defines the tables you would like to insert into. In our case, we only have one table, the URLs table. Then, for each table, you define an array of rows. Each row will contain an associative array containing the column name and the value of the data you would like to insert. In our dataset, we are adding 3 rows. The exact content you enter will usually be driven by what you need to test in your test case. For us, these 3 rows provide a good foundation for all of our tests. There are usually 2 different variants of tests that you will create. The first are tests where you are just reading data from the database. These are the easier of the 2 variants to write. Take a look at test getURL returns existing URL. Here you can see that we are calling getURL with a shortened URL that we specified in our dataset above. URL repository is then pulling that data out of our test SQLite database and returning the appropriate URL entity object. Then we can insert all of the data in that object. Now take a look at test add URL. As mentioned before, this type of test can be a little bit more complicated. We are modifying data in the database that we'll need to verify after the test. In this test, we are creating a URL entity to insert, and then we are calling add URL. To validate the data in our database, we are then creating what is called a query table. This is just a class representation of tables within a dataset. PHP Unit also allows creating them using a query, which can make them significantly easier to work with. We can leverage 2 different methods in the query table to assert the data. The first is getRowCount. We are using this to make sure the query only returned a single row. Then we can use getValue to read data from the query result. The first parameter specifies the row you want to read. The second parameter specifies the column from that row. You will notice when we assert the timestamp, we are passing a 4th parameter to assert equals. This 4th parameter is a convenient way to tell PHP that you are okay with numeric values being slightly off. This works well when time is used, as you cannot guarantee that both calls to time are happening in the same second. There are a few more tests that we won't go over. However, feel free to explore more in the URL repository test class yourself. For now, let's run PHP Unit and make sure our database tests pass. There they are. Great job! In this video, we learned how we can use PHP Unit's database extension to test our URL repository. In the next video, we are going to look at how we can use Selenium to implement functional tests to ensure that everything in our application works from end to end. Welcome to the 5th video of this section, Functional Tests with Selenium. In the previous video, we learned how we can easily create database tests. We are now pretty capable at testing most types of classes we will encounter in our application. However, there is still value to be gained from having some tests that are able to validate our application end to end. In this video, we are going to learn how to write functional tests. First, we will install Selenium, a web browser automation platform, onto our host computer. Then, we will prepare our application to use Selenium with PHP Unit. Finally, we will look at how we can build a Selenium test to ensure that a URL can be properly saved into our system. Let's get started by installing Selenium. The website for Selenium is seleniumhq.org. Selenium is a fantastic tool for testing that essentially allows you to use code to automate a browser. We are going to use it in this video to automate the Chrome browser. We need to install a couple of things on our host. First, let's grab the standalone server. Then, for Chrome, we will also need to download the Chrome driver. When the download is complete, move both files into our PHP Projects directory on our host. Now we need to unzip the Chrome driver. This should be all that we need to do. Now you can start the Selenium server by typing java-jar and passing it your Selenium server jar file. Great! Go ahead and exit it for now using Ctrl-C. Now let's set up our project so we can use Selenium. Using Composer, we can install the Selenium extension for PHP Unit called PHP Unit /PHP Unit-Selenium. However, if you do that, you will find that Composer will complain about not having the curl extension. So let's use Puffpit to install that first. In your PHP Projects directory on your host machine, open puffpit/config.yaml in your favorite editor and look for the PHP section. Underneath modules in PHP, we can add the curl module. Now run vagrant provision. Once that completes, go back to your VM and run php-ri curl and make sure the extension is installed. If it isn't, you may need to go back and ensure that vagrant provision ran successfully. We should also make sure Nginx picks up the new extension by running sudo service nginx restart. Now we can use Composer require --dev PHP Unit /PHP Unit-Selenium to install the Selenium extension. Take a look at composer.json and you should see that Selenium is in our dev requirements. Similarly to what we did with our database tests, we should now create a base class for our Selenium tests. Check out Selenium test case in tests. The Selenium extension for PHP Unit adds the class PHP Unit extensions Selenium2 test case. This is the base class for all Selenium tests. It provides many functions that you can use to perform actions on the page as well as retrieve data from the page. Unfortunately, the best documentation for this extension at the moment is the source code itself. In particular, you should look at the class documentation block. Some of the more important methods are the various by methods, such as byId or byCSS, that let you select elements on a page. The URL method can return the URL of the current page, or if you provide a URL, it navigates to that URL. There is even an execute method that allows you to run JavaScript in the browser. With Selenium test case, you can specify one or more browsers you want to test using the static property browsers. It accepts an array of configurations. We are specifying the Chrome browser. Port 4444 is the default port of the Selenium server, and then 192.168.56.1 is the IP address for your host. This is where PHP Unit will attempt to connect to Selenium. If we wanted to test on multiple browsers, we could add another section here and change the browser name maybe to Firefox. Then our tests would run in both browsers. Now we need a place to put our feature tests. It is often a good idea to be able to run your feature tests separately from your unit tests. They typically take significantly longer to run, and you probably don't want to have your Selenium server running all the time. The easiest way to do this is through a separate directory. Let's add a new directory called Feature Tests. We'll mark it as a test sources root. Now go back to your host and restart Selenium. Then, in your VM, you can run your functional tests by running vendor/bin/PHP Unit feature tests. We don't currently have any tests, so let's add one. We are going to add a test that makes sure after we add a URL, it is forwarding us to the stats page with all of the fields properly displayed. Go ahead and create a new file in feature tests called addurltest.php. Set the namespace, create the class, and make sure you extend Selenium test case. Now, we need to add our test method, test_add_URL. First thing we need to do is load the proper URL. You can do this using the URL method. We are going to load url.dev. Next, we need to fill out our form. Open views/index.php, and you'll notice we have set the IDs for the input box to URL and the submit button to shorten. In our test, we can now use the byId method to reference these form elements. You'll notice through autocomplete that there are several other ways we can select elements. Most of them are pretty self-explanatory. So we will call byId URL. Now, you can see once again we have a list of methods to choose from. Some of these are a little less obvious, but they use roughly the same names as you would expect from HTML elements. When you want to send text into a text input or a text area, you should use the value method. If you are ever unsure of what one of these methods do, you can look at the documentation in the Selenium extension. Let's set the value to google.com. Now we can select the shorten button, and here we will use click. This will emulate clicking the submit button. Now we'll run the test. Nothing exciting happened, but the test did pass. Let me make my PHP Storm window smaller and we'll run it again. This time you should have seen the browser briefly appear. Alright, now we need to verify what we are seeing on the second page. We can find out the URL of the current page using the URL method with no parameters. Let's store that to a variable. Then I'm going to use a regular expression to ensure we are on the proper URL. Notice that I am capturing the value of the URL parameter that contains the short URL. We can use that later to validate that the shortened URL in the page header is correct. Now we can assert that we are on the proper URL. Run the test again. It is still passing. Now we need to find a way to check the content of the page. So let's open views/shortened.php. The easiest way to do this is to find the pieces of content you want to check and make sure they are in an element with an ID or a class that you can use to select that element in Selenium. We are going to assert the shortened URL, the target URL, and the redirect count. So let's add a span tag around the shortened URL with an ID of shortened URL. We will do the same for target URL, obviously using a different ID. Then, we already wrapped the redirect count in a bold tag, so we can just add the ID of redirect count. Now, back in addURL test, let's add our assertions. First, let's run pregmatch on our URL with our regular expression again, so we can capture the shortened URL. Now we can add an assert equals call. First, we will compare the shortened URL. To pull the shortened URL from the page, we can use the byId method with shortened URL as the parameter. Then, to get the text of that element, we simply call the text method. Now we can duplicate that line a couple of times. Change the second check to make sure target URL equals google.com. Then, change the third check to make sure redirect count equals 0. Run the test one more time and make sure it still passes. Great job! In this video, we were able to install Selenium and get our first functional test running. In this section, we have covered many of the types of testing you need to ensure your project is successful. We discovered how we can add PHP Unit to our projects. We learned how the basic structure of a unit test is laid out. We used mock objects to make testing some of our classes with dependencies a little easier. We implemented our first database test, and we implemented our first functional test. All along the way, we were able to use this testing process to spot how we could improve our code. In the next section, we are going to start a new project. We will use what we have learned from this section to take a test-driven approach to creating a user management system. Welcome to the fifth section of PHP Projects, Creating an Authentication Platform. In the previous section, we learned how we could use unit tests to improve the quality of our project. In this section, we will take what we learned about testing and combine it with a test-driven development approach to create an authentication system. This system will allow you to manage users, groups, and permissions. Along the way, we will see how our test-driven approach allows us to confidently refactor duplicate code in our system. We will also use it to add new features such as bootstrapping login for the system. In this video, we will set up the foundation for our project and a few tests. First, we will learn how this project has been structured as its own repository. Then we will go over the basic framework of the project. And finally, we will take a look at the tests we have written that will verify the code we write in the next video. Great, let's get started. To kick this project off quickly and to make it easier for you to follow along, we are going to set up this project using GitHub. Open your browser and load github.com/phpprojectsvideo/authdev. This is the repository that hosts all of the code for this video. Click on the clone button and copy the GitHub URL. Now in PHP Storm, we can check out from version control. Make sure you choose Git, not GitHub. Paste in the URL and click Clone. Once PHP Storm is done checking out the project, it will prompt you to open the directory. Go ahead and click on Yes. Now, in PHP Storm, click on the Version Control tab at the bottom and click on Log. You can see all of our commits in this window. You'll notice that I've tagged the proper source for each video. Right-click on the 5.1 tag and choose Checkout Revision. Now, we are looking at just the code necessary for this video. Before we jump into our code, let's get our new VM running. If you have other VMs running from our previous sections, you need to shut them down using either Vagrant Halt or VirtualBox. You'll notice in our project there is a Vagrant file as well as a Puffpit folder. I went ahead and created a new configuration that we could use following much the same process as we used in the first section. Now, you can just run Vagrant up in your terminal and it should set up our VM. While that is starting up, you can also add a new domain, auth.dev, to your etc host file. I set this box up using the same IP as url.dev from the previous sections, so you can just add auth.dev to the end of that line like you see here. Alright, let's close the terminal for now and take a look at our code. Open gitignore. When we are setting up a project using Composer and Vagrant, there are a few different directories we want to make sure don't get committed. Most of these directories are automatically generated directories from either Vagrant, Composer, or PHP Storm. When working on a project with multiple developers, this makes it much easier to collaborate as it greatly reduces the number of conflicts you will have with each other as you make changes. In the auth.dev directory is the core of our code. Let's start in the www directory. Open index.php. Our index.php file is very simple right now. We are going to continue adding to this file throughout this section. It will act as our front controller or router for all future pages. As we add more pages to our site, this will make it easier for us to use friendly URLs. For now, we just throw an exception to indicate that the requested content was not found. That exception is then used to display our 404 page. Let's take a look at how that works in our error controller. Here is the controller action for a not found page. You'll see that it is using a class called viewService to issue headers and display our view template. We are using a separate class for this now as opposed to directly in the controller like we did for the URL shortener. You'll also notice some goofy syntax on our create method. In PHP 7, a new feature was added that allows you to declare return types. This helps make sure you are following your documented contract when writing your methods. If you attempt to return anything other than an error controller here, PHP would throw an error. The other classes in Source are fairly simple and straightforward. We'll talk more about some of them later on in the section. Now let's look at tests. If you open Database Selenium Test Case, however, you'll see something a little bit different. This is an abstract class that combines both a Selenium functional test as well as a database test into a single test case. This allows us to run functional tests that are still data dependent. The database functionality of this class is provided by a trait called Database Test Case trait. Traits allow you to use PHP to compose your classes from smaller units. So when you use a trait, as you see here, it essentially adds all of the methods and properties defined in that trait directly onto the class using them. You can learn more by searching for trait in PHP's documentation. The database test case trait is really just a copy of the database test case we wrote for our URL shortener. The setup page method is called by PHP Unit's Selenium extension after it has established a Selenium session with a browser. It allows you to do work before every test that might be necessary to set up your browser. You'll notice I am using it to visit our site with the IM-WebDriver query string parameter. Open source/bootstrap.php and you can see what we do with that parameter. If that parameter is set, we are taking it and turning it into a cookie. We then use that cookie to help us determine what database we are going to use for handling requests to the site. This is critical as Selenium tests, unlike typical tests, will load your website in a browser. If we did not do this, we would run the risk of our tests writing data to and from the production database. I do have some safeguards in place to help make sure that this cookie is only observed when using our testing domain. If you open our test-bootstrap file, you'll see some new stuff here as well. This code is checking to make sure that our test database exists. If it does not, we will run SQLite to build the database using SQL statements stored in schema.sql. You can open this file to see those statements for yourself. Alright, let's take a look now at our functional tests. Open User Management Test. This test case contains several tests that are making sure that when we implement the ability to manage users, we will cover every required use case for that functionality. You'll see several different use cases being tested from the basic list to pagination to the ability to add and remove users. You'll see the dataset at the top of our test. This data will be entered into our testing database prior to the run of each test. Because of our WebDriver cookie, that data will be interacted with when Selenium controls the browser to visit our site. Take some time to go through some of the code in this test case. It does much of the same things that we did in the previous section, but there are significantly more examples. Alright, let's go back to our terminal. Vagrant should be done building by now, so let's type in vagrant SSH. Change directories to /var/www/auth.dev. We need to run composer install to pull in all of our dependencies. I'm going to fast forward through this process. Alright, now that Composer is installed, let's set up our database. While our tests will create their own database, we do need to run the update schema.php script to build our development database. First, create the data directory where the databases will live, then run php update schema.php. Now we can run our unit tests. Run vendor bin PHP Unit. Now let's run our feature tests. You'll notice Selenium has been packaged with this project, so we can open a new tab in Terminal and start Selenium with java-jar. Now go back to the first tab and run PHP Unit against our feature tests directory. We will fast forward through this test process. You'll notice most all of our tests have failed. This is to be expected as we haven't implemented any of our functionality yet. If you go back to your project, however, you will see a new artifacts directory. Open that up and you'll see several PNGs. These are all screenshots that Selenium took at the point where each of your tests failed. Between these screenshots and the notes from the test failures, it should help us determine why our tests are failing when they do. This was implemented in our database Selenium test case using the onNotSuccessful test method. This method is ran by PHP Unit whenever one of our tests have failed. In this video, we got our newest project off the ground and put together some functional tests to help guide our next steps of development. In the next video, we are going to write the code necessary to make our user management tests pass. Welcome to the second video of Section 5, Implementing User Management. In the previous video, we reviewed our user management test case. This test case was written to help us ensure that when we implemented user management, it had all of the functionality required. In this video, we are going to take that feature test and create all of the code required to make it pass. In doing so, we will have a fully functional user management interface. First, we will review how to go from a feature test to a unit test to your final code for your classes. Then, we will walk through some highlights of how our user management functionality was implemented. We'll see how to leverage PHP's password hashing functionality. We'll review a simple implementation of cross-site request forgery protection, and we'll take a peek at generators. Finally, we will see if we finished our job and got all of our tests passing, as well as take our system for a test drive with some manual tests. To get started, go to your version control tool and make sure you are in the Log tab. Now, we want to check out version 5.2. This will pull in code that implements the required functionality for all of our user management tests. As a matter of habit, whenever we check out new code, we should both delete our test database in data and run php update schema.php just to make sure we have the freshest schema. You'll remember from our previous video that we had implemented several different functional tests in our user management test file. Even though the code is already written, let's take a look at the first test in user management test and see how we could approach implementing that functionality. Take a look at test listing users. In this test, we are loading the auth.dev/users URL. Then, we are looking for an HTML element identified by user list, and from there we are using XPath to retrieve a table row. That row contains a table cell with the text taken.user01. Then, using that table row, we are checking the text in each one of the cells to ensure that our user appears. We could feasibly do the same thing with all of the users added in our dataset. The first thing we should notice is that this test does assume a few things about the HTML for this page. It is assuming we have an element with the ID of user list that is or at least contains a table. Then it is assuming that column 2 will contain usernames, 3 will contain the name, and 4 will contain the email. Since we know these basic things about our HTML, we can start with creating our view. Go to views/users/list.php. You'll see the full HTML for the page, but for right now we want to focus on that user list table. You can see that we have our table with the correct ID. Headers have been added for the various columns, and we know that we want to display users in this table, so we could go ahead and assume a users array containing our user entities. We can even start assuming some of our entity functions here to pull the usernames, email addresses, and names. Since we are starting to understand what our entity needs to look like, we can start writing some tests for that entity. Open user entity test.php. Before we even write a line of code for our entity, we can start establishing with our unit tests how that entity needs to function. You can see here in our setup, I've created a user entity and using setters added data. Typically, when creating entities, you should allow an ID for that entity to be passed into the constructor. Remember, an entity is a business object that has a distinct and important identity. Now, we can write a couple of tests to ensure that when we create and update entities, everything can be retrieved as expected. At this point, we can create our entity. Open up userentity.php. Here you can see our constructors, the update from array method, and the various setters and getters we just started testing in our test. As you begin to implement these functions, you can continue to run the test with PHP Unit to measure your progress. You don't have to just implement your solution end-to-end and hope it works. Once our entity is complete, the next place to go would typically be the controller. Again, you can start with the user controller test first. We can start making some assertions with what our controller method that gets the list page should do. We know we will want to get a sorted user list from a repository. We will say we should grab 10 rows. Then, in order for us to know whether or not we should paginate, we will need to get the total number of users. Finally, we know we are going to need to render our users list view. It should be mentioned that the first time we write this test, we may not be concerned with either searching or pagination. As your feature set evolves, you will find your tests evolving as well. Now, we have established the beginnings of the interface required by our user repository. We can continue to repeat this process, identifying necessary functionality of classes, implementing tests for those classes, and then writing the code for those classes using our tests as a checkpoint for when we are done. Finally, you would tie it all together by adding the controller to your router. In www.index.php, you will see that we explode the paths in the URL and use the first component to see which controller we should load. Then, the second part determines the action method on that controller that we will call. So let's take a look at some specific PHP functionality we have introduced in this code. Open user entity and go to the set clear text password method. You'll see here we are using a new function, password_hash. This is a function that was introduced in PHP 5.5 that allows us to easily hash passwords for storage using best practices from the security community. It allows you to perform repeated hashes using the cost option to help make brute force attacks significantly harder. You will see later on in this section we will use password verify that then takes a plain text password and validates that it matches the hash generated by password hash. There is even a function password needs rehash that you can use in a sense to upgrade your password hashing. As either new hashing algorithms are released or you need to increase the cost of hashing due to hardware improvements, you can seamlessly do that with this set of functions. Another security aspect we have introduced in this project is cross-site request forgery or CSRF protection. We are doing this with a basic token that we both store in our session and send to the page as a hidden form element. Open user controller and go to the getNew method. This method displays a form to add a new user. You'll see we call the getNewToken method on CSRF service. This uses a secret key, the user's session ID, a random string, and the current time to generate the hash that is both stored in the session and returned to the caller. Then, in the user controller's saveUser method, you'll see that validateToken is called on the token value. Here, it makes sure that the token exists in the session and hasn't expired yet. The one thing missing here is an ability to prune the tokens from your session. This would get important over time and could easily be implemented by removing the oldest token whenever you have more than X number of tokens added. The last thing we should take a look at is in our user repository. Look at getSortedUserList. You'll notice in the middle of our for each statement, instead of building an array, we are calling the yield function. This is taking advantage of the PHP 5.5 feature generators. A generator is a way to create an iterable response from a function without consuming all of the resources necessary to hold the entire object or array in memory. So when you call this method, it is going to execute all the way up until the first yield function. Then it will hand control back to the caller. When you begin iterating over this object using a for each loop, it will return the value of that first yield and then continue in the function where it left off until it hits another yield statement. This is not necessarily the best use case for generators as they do add some complexity and limitation. For instance, you can't iterate over a generator more than once. However, this felt like a good opportunity to show that functionality. Alright, let's go to our terminal and start up Selenium so we can see if our tests are passing now. First, we should run our unit tests to make sure there are no obvious problems. Now, let's give your feature tests a spin. They look good. Great job. Now let's go to our browser and check it out for ourselves. You'll want to load auth.dev/users. We can browse around, add a user, remove a user, and just see if everything's working right. It looks great. In this video, we further explored how we can use test-driven development to create the user management functionality of our authentication system. In the next video, we will build out a similar system for managing groups and then see how we can manage relationships between our two entities. Welcome to the third video in this section, Managing Groups for the Users. In the previous video, we added user management functionality to our system. In this video, we are going to focus on adding group management functionality. We will start by briefly going over the high-level steps taken to implement groups. Then, we will take a look at how we can model the relationship between two distinct business entities. Finally, we try out our new ability to assign groups to users. We will start out by checking out the code for video 5.3. You'll notice in our log panel that there are several intermediary commits between some of our videos. The commits in this Git repository are meant to show you at a high level how it would typically progress through a project like this. Feel free to explore each commit individually, as it can give you some insights into how we could tackle this problem. For instance, our first commit was really about providing symmetrical functionality between users and groups. Then, since we didn't have any precedence for how to lay out the interface for adding groups to users, the second commit implemented the HTML in the view required to provide this interaction. Finally, the third commit added the necessary tests using our HTML as a springboard, and then similarly to the last section, we made the necessary changes to the entities, repositories, and controllers to support this new functionality. Before we get too far, let's do our customary deletion of the test auth database and run update schema.php. Alright, let's crack open some code. As you look throughout the tests, controller, entity, repository, and other supporting classes for groups, you will see that much of the structure is almost identical to that of the users. Really, the only major difference between it and users is the number of fields and aspects around the validation of those fields. So, why don't we focus in on the unique aspect of adding groups that didn't apply when we only had users? That is the aspect of adding users to groups. We want our system to allow adding any number of groups to any number of users. When dealing with many-to-many relationships like these, there are a few things that you want to keep in mind. From the database perspective, you will almost always use a join table. Open schema.sql and you'll see not just our groups table, but a new users groups table as well. This table is how we will store the relationships between our groups. Both users and groups are what we call aggregate roots. That is to say, they are both entities that we would very likely access outside of any other entity in the system. A non-aggregate root entity would be an entity that maybe only has meaning when in the context of one of our aggregate roots. For instance, if we had an address table and a separate entity for that address, we would likely only access that address through the user that owned the address. When you have two aggregate roots like a user and a group that are related, you are best off determining an owning side of the relationship. In our case, we're going to make the user the owner. Go ahead and open userentity.php and scroll down. You'll see our add groups, remove groups, and get group IDs methods. I highly recommend that when you deal with representing the relationships between two aggregate roots in your models, you represent it using your entity IDs. So, when we pull a list of groups for a given user, we will not actually pull all of the group entities, we simply return the IDs. Now jump over to user repository and check out the get user by username method. You'll see here where we are selecting our user by username. Once we have a user, we issue a second query that pulls all of the group IDs for that user and adds them to our entity. Likewise, in the save user method, once we save our user, we are only having to manipulate rows in our user groups table to add and remove groups as appropriate from the user. Using only these IDs means there is never a need for us to make modifications to the group table when persisting our user. This is a common tactic that you see many of the best domain modelers using in their software designs. Now, if you go to our user controller and scroll down to post update groups, you will see how we tie all of this data together. We are pulling in all of the group IDs that we are adding or removing as a single key containing an array of group IDs in our post data array. Then, depending on our operation, we are either adding those groups to our user or removing them from our user. Then, once we save the user, the appropriate groups will be updated. Pretty simple, right? Let's jump into our browser and give it a try. First, let's add a user. Now, let's jump over and add a few groups. Then, go back to our user list and click on the user you created. You'll see the user group list is empty. Let's select a couple of groups and add them. The additions were successful. Now, let's remove one of them. Very good. Alright, you can dig further into the code yourself and be sure to run the unit tests and the feature tests. In this video, we extended the functionality of our authentication management system by adding group management and allowing the assignment of groups to users. We mentioned several times how similar the code to manage users and groups was. In the next video, we are going to explore how we can refactor this code with the protection of our tests to make sure we are not repeating ourselves. Welcome to the fourth video in this section, Drying Out Group and User CRUD. In the previous video, we added group management functionality. We noticed through the process of doing this that the create, read, update, and delete, or CRUD functionality between users and groups was very similar. In this video, we are going to work on enforcing the do not repeat yourself, or DRY principle in software design. We are going to take a look at how similar the controllers and repositories for our users and groups are. Then, we are going to go over how we can create a single base class that abstracts this functionality away from users and groups, so in implementing permissions into our model, the work will be significantly easier. Finally, we will review and run our tests to make sure that nothing in our system broke as a result of our refactor. Before we update our code, let's take a look at where we left off in the last video. Let's open both our user repository and our group repository. Move the group repository to the right pane so we can view them side by side. You should see as you scroll down, we really repeated almost the same patterns between our groups and our users. There are a handful of minor variations, but other than the names of variables, tables, columns, and methods, the general code behind each method is the same. Whenever you find yourself repeating patterns like this, it is an ideal candidate for refactoring so you can stop the repetition. Let's see how we can do that. Take a look at getSortedUserList and getSortedGroupList. Beyond the name, the first difference you see is that getSortedGroupList has an extra conditional branch of logic, allowing you to not specify a limit. This was used in the user detail page to make sure we pulled all groups, so we could add or remove any group to or from our user. This is something that wouldn't be used right now in user repository, but it wouldn't hurt to add it. What are some other differences? You can see that the column lists we pull, the table name we pull from, and the column we sort by are all different. Lastly, the code we use to convert our database row data into an entity is also different. What if we took all of these differences and pulled them out into their own methods on our class? Then, by simply extending our class and changing what those methods returned, we could quickly create a new repository handling this basic functionality and hardly have to write any code. Well, enough what ifs. Let's see how it would work out. Go to the version control panel and let's check out the changes we made between video 5.3 and video 5.4. We can start with looking at how we generalized the group repository. If we open group repository, you can see the changes that we made to getSortedGroupList. Just like we discussed, we took those pieces that were different between users and groups and pulled them out into well-named functions. Scroll up and we can review the new methods that we have extracted. We start out with methods that allow us to create database rows from entities and then from rows back to entities. We created a method to return and set the ID in our entity. Then we have a handful of methods to return the table name, column lists, sort column, and friendly lookup column. This is really all we need to change in order to swap out what entity our repository works with. Close that diff and take a look at what we changed next. Go ahead and take a peek at the creation of the base Simple CRUD repository class. You can see that we went ahead and made it an abstract class. Each of the methods we extracted from the group repository are now abstract methods in this class. The rest of the class is identical to our group class. Now, let's go ahead and check out the code for video 5.4. Then delete our test database and rebuild our production database. Now, take another look at our two repositories. You'll see that they are now extending our simple CRUD repository. You'll also notice that they have significantly less code. In fact, our group repository does nothing other than implement our abstract methods. The user repository, as you'll remember, has some special functionality. It needs to do some extra work to manage the relationship between groups and users with our join table. You'll see that this is accomplished with three special methods: on single entity load, on single entity save, and on pre-multi-entity delete. Open simple CRUD repository and you can see how we implemented on single entity load. Find the getByFriendlyName method. Once we have loaded our row out of the database successfully and converted it into an entity, we send that entity to the onSingleEntityLoad method. The default implementation of this method does nothing. However, in the user repository, we have overridden it to load our group IDs from the user's groups table. Now, open User Controller and Group Controller. We followed a similar process here. You can see in our group controller that we have simply implemented a series of abstract methods from a new simple CRUD controller class. In User Controller, we have done the same thing with the addition of a few other hooks. One to handle adding groups to our detail render, adding our password confirmation to validation, and then we still have a separate action method for handling updating groups. Take one final peek at our version control, and you'll notice that in all of the commits between video 5.3 and 5.4, we only made small alterations to our tests to help support proper renaming of methods and other elements after we genericized them. This allows us to lean very heavily on these tests to make sure our refactoring is successful. Why don't we try running them? Open up a new tab in Terminal and start Selenium. Now run our unit tests. They pass with flying colors. Now let's try our feature tests. Once again, passing with no issues. Awesome job! In this video, we leveraged our comprehensive test suite to help us refactor our code to follow dry principles. In the next video, we are going to take advantage of those refactorings and see how easy it is for us to roll permission support into our management interface. Welcome to the fifth video in this section, Giving Permissions to Our Groups. In the previous video, we did some heavy refactoring supported by our tests to make it easier to allow for CRUD operations through repositories and controllers against new entities. In this video, we are going to see how we can take advantage of these improvements in adding permission support to our system. First, we'll take a look at our basic entity and understand its validation class. Then, we'll see how simple it was to create our new repository and controller. After that, we will take a look at how we can establish our relationship between groups and permissions in a fashion similar to what we did with users and groups. Let's get rolling. We are going to start out by checking out the code for video 5.5. Then, let's set up our databases. Now, let's take a deeper look at our entity and how validation works. Up to this point, we haven't really dug deeply into that part of our application. Open up permissionEntity.php, and you'll see that this entity is very basic. Just a couple of getters and setters, as well as methods to help with entity creation and population of our entity data from databases and forms. Open up Permission Validation. Here, you will see how we handle our validation of permissions. Each one of our entities has a similar class containing a validate method that accepts an instance of our entity. The validate method will check to ensure that all of the fields in the entity contain valid values. It then returns a validation results object. Take a closer look at the validation results class. This is a basic value object that allows us to store validation messages in validation state for any of our model entities and forms. You can either pass in an array of element names and their associated validation errors, or you can use the add error for field method to add a single message at a time. A result is considered valid if there are no messages added. You can retrieve your validation methods a single field at a time. You could easily do all of this just using arrays, but sometimes it makes your code much more explicit by creating simple objects like this to make your intentions on how the object should be used clear. You can see what I mean by taking a look at the permissions form view. You can see where we check for errors in the particular fields, and if they exist, we alter the UI so the user can understand what the problem is. Now, let's take a look at permission repository. You'll notice the implementation, similar to a group repository, is really just updates to table names, columns, and entity classes. This is a significantly smaller class than what we would have to write if the simple CRUD repository did not exist. Now let's open the permission controller. Once again, everything here is very straightforward. We just have simple implementation of our abstract simple CRUD methods. Using our simple CRUD classes, we have turned the process of adding new entities into our system into a very easy one. We just create classes, specify simple values for abstract methods, put together a few templates, and we are done. Our refactoring in the last video has certainly accomplished its goal. Let's take a peek at the changes we made to the group entity. You can see once again we are using our entity IDs to establish the relationship between groups and permissions. Maybe you have noticed that we do have one method that interacts with a complete permission entity, isOwnerOfPermission. When you are not persisting an entirely separate aggregate root entity for the purpose of writing it out later in your repository, there is nothing wrong with passing actual entities. In fact, oftentimes it can lead to a richer and easier to understand domain model. In fact, there are some ORM systems that allow you to very easily do this kind of thing with the added benefit of pulling in the full information for that entity when you need it. We will take a look at some of these technologies later on in this series in Section 7. Now, in Group Repository, you see where we are injecting the operations on the group's permissions table. This is all structured similarly to how user classes were modified to support addition of groups to users. If we wanted to, I bet we could employ another refactoring session to abstract this functionality out just like we did our basic CRUD functionality. If you open the group controller, you will see where we have added onGetDetailRender to display our permissions in the template, and post-update permissions to save our group permission relationships to the repository. We definitely simplified our system in the last video to the point where the implementation of new features and functionality is getting easier and easier. In this video, we have added the ability to manage permissions to our application, leveraging our simple CRUD foundation from the previous video. In the next video, we are going to put all of this data we are managing to use by allowing us to use our users and permissions to log in to our own system. Welcome to the sixth and final video of this section, bootstrapping authentication to our management system. In the previous video, we added the ability to set permissions for groups into our system. In this video, we are going to secure our interface using its own user, group, and permission system. Now, in order to modify the data in our system, you will have to have permission to do so. First, we will take a look at how we can modify our functional tests to take into account the fact that we will now need to log in. Then, we will look at the new views and controllers we use to handle logging into and out of our system. Then we will take a look at how we can use a trait to quickly enforce login across our various controllers. As is tradition, let's check out the proper code for this video. We are now in video 5.6. Rebuild the database, and let's get started. First, let's open User Management Test. Our goal in this video is to make sure we can force users to log in before they are allowed to edit or even view any of the data in our system. What will this do to our tests? Now, as soon as we attempt to view a list page, for instance, we will just get redirected to a login screen and our tests will fail. Does this mean we need to add code to the beginning of each test to allow us to log in? Well, sort of, but it isn't too bad. Let's take a look at the changes we made to User Management Test. Scroll down until you find the Setup Page method. You may remember from a few videos ago, the Setup Page method is similar to PHP Unit's setup method. However, it is only run once we have a Selenium session established with the browser. We can use this method to implement our login one time in each test case in a way that allows it to affect each test. The implementation of this method is very simple. It just needs to browse to the login page, enter a username and password, then it needs to click the login button. Once this is done, the user will be logged in and we can move forward with our normal tests. In order for this login to work, we do need to make sure we have the appropriate data for this user in our database. Scroll up and take a look at our data set. You can see that I am now using a legitimate password for each of our users. I am also adding a new administrator permission and establishing all of the data necessary to link that permission to the user identified by taken.user09. You'll see a similar change across the other two entity-based functional tests. Now, let's take a look at the login test. Here, you can see I implemented a similar dataset but with far fewer users. As you scroll through the test case, you can see that we are testing all of the various aspects of our login system, making sure it directs you to the proper page, restricting permissions when necessary, and letting you log out whenever you want. Let's see how this functionality has been implemented. Let's start out in our login controller. You'll see that we have three different methods. GetLogin is used to display our login form. However, if a user is already logged in, we really don't want to display this form. We are using the login service to determine whether or not that user is logged in. In the post-login method, we are accepting the data from the login form and again using the login service to attempt to authenticate that user. If it is successful, the returned validation result will be valid, and if the CSRF token is valid, we can redirect them to the page they came from. If the username or password fail, or the CSRF token is invalid, we redisplay the login form with the appropriate warning or notice. Finally, in the post-logout method, we remove all traces of authentication and again redirect the user back to where they came from. All of the functionality dealing with logins is implemented through the login service. This gives us a one-stop shop for all of our authentication needs without having to add a larger number of dependencies to our login controller. Let's take a closer look. You can see that it accepts a user repository, a permission repository, and a session store as its constructor parameters. The session store is used to store whether or not the user is logged in. You can see in isSessionAuthenticated that we are confirming this simply by looking at the data in that session store. In attempt authentication, we are using the given username and password to try and log a user in. First, we pull the user entity from the user repository by username. Then, by calling password matches on the existing entity, we can validate the user and password. Password matches uses the password verify function that we discussed earlier in this section. If the password is successfully matched, we set the session as authenticated and return a valid result. Otherwise, we return a validation result with an error message. The remove authentication method simply unsets the authentication data from our session. Then, there is a method we haven't used yet called sessionHasPermission. This will check our current session, grab the user from the repository with that username, then it will look up all of the permissions based on the groups that the user is a member of. If any of the permissions match the passed-in name, true is returned. You can see the richness of our domain model starting to peek through now. Open up the base template view real quick. You can see in our navbar we are now using this login service to determine if a user is logged in from directly within the template. When you have large cross-cutting concerns like authentication, it is perfectly fine to use a well-defined interface to access these services from directly within your template. Many template languages such as Twig will allow you to do this by adding extensions containing various functions or globals. Since we are just using PHP as our templating engine, this is the rough equivalent of that same Twig customization ability. Alright, so we can now log in and out. How do we make sure these logins are forced for our various controllers? Well, we could just implement authentication separately in each controller, but we already learned how time-consuming repeating yourself can be. Maybe we could just implement it directly on our simple CRUD controller. This would probably work just fine, but what if we wanted to have the ability to be very explicit in each controller about whether or not permission was necessary. Maybe we can get the best of both worlds. Open Simple CRUD controller and scroll down to the get list method. You'll see that we now have a simple guard check to ensure that a user has the requested permission, in this case administrator. In Simple CRUD, that method just always returns true. So by default, a user will always be allowed to run any of these controller actions. Now, in each controller where we want to force login, we can simply override this method and run checks against the login service. However, that kind of goes against our now beloved dry principle. We don't want to copy that same function into each one of our controllers. This is another area where traits can help us. Again, traits allow us to use PHP to compose classes. You can almost think of it as a language-level copy and paste. When you use a trait in a class, all methods and properties in that trait are pasted into the using class. Open up User Controller. You'll see at the top of this file we are using permissionable controller trait. Let's check that trait out. You'll notice that it has implemented a check for permission function. This check for permission function does require both a login service and a view service. Since we know most of our classes will contain a view service, we have made this method abstract so we can implement it in the classes using this trait. Now, we just need to simply use this trait in any of our existing controllers, and just like that, authentication is forced. Open up schema.sql real quick. You'll see that as a part of our schema setup, we are adding a user admin with administrator permissions. We should be able to use this information to log into our test site. Let's give it a try. The username and password are both admin. It worked. Great job. In this video, we successfully implemented authentication into our authentication management platform using PHP's traits. In this section, we successfully used a test-driven development approach to create an authentication system. This system allows you to manage users, groups, and permissions. Along the way, we saw how our test-driven approach helped us to refactor duplicate code in our system, as well as adding powerful features such as authentication and access controls. In the next section, we are going to expand our authentication platform into a service that we can scale separately from the applications that use it. Welcome to the 6th section of PHP Projects, converting our user management application into a scalable service. In the previous section, we created a user management service that we could use through our browser. In this section, we will learn how we can modify our application to provide a scalable, RESTful interface. There are many different definitions of REST, so we will start by going over what true REST is. Then, we will create a REST interface for our application, leveraging some of the code we have already put in place for our controllers. Then, we will focus on how we can scale. We will migrate from SQLite, a local database engine, to MySQL, a fully featured database server that will scale much more easily than SQLite. Then, we will move from file-based sessions to MySQL-backed sessions, so we can access our sessions across multiple web servers. Finally, we will introduce caching using Memcache to help remove the potential bottleneck of our database and see what kind of performance boost that gives us. In this video, we will discuss the basics of what REST is and how we will implement it. First, we will go over how we can leverage PHP Unit to help us test our web service. Then, we will go over what the qualities of a RESTful API architecture are. Finally, we will go over what we want our RESTful endpoints in our user management API to look like. Similarly to the last section, you can check out the code for each video in this section from GitHub. Every video will again have its own tag in the repository that you can check out using either PHP Storm or the command git fetch to make sure that you have all changes from GitHub, followed by a git checkout v6.1 to check out the appropriate video's code. We should discuss the basic foundation of a true RESTful API. Before we do this, however, let's look at how we can use PHP Unit to test web services, specifically RESTful APIs. This will then allow us to use a test case to show the fundamental qualities of a REST API. Open composer.json. You'll see we have a new development dependency, guzzle HTTP/guzzle. Guzzle is a PHP HTTP client. It accomplishes much the same things that you can accomplish using PHP's curl extension, however it has a much less verbose, easier to use interface. We are going to use this in a PHP Unit test case to help us run feature tests against our API, much like we use Selenium to run feature tests against the website. We will spend some time in our next video reviewing the functionality of Guzzle and how we have set it up. For this video, the example should be easy enough to understand to allow us to review the basic concepts. Alright, now we can talk about what a REST API actually is. Over the years, the term REST has been given several definitions, each varying a bit in scope. The term REST stands for Representational State Transfer and was coined as an official term in 2000 by Roy Fielding. In order to understand REST, we can take a look at it through the lens of Richardson's Maturity Model, or RMM. This is a measurement of how RESTful your API really is. In the RMM, there are 4 different levels of maturity, with each level taking you one step closer to true RESTfulness. Let's start out at level 0. Open the Maturity Levels API Tests class in API Tests. In our test case, you can find an example of a level 0 API in test level 0. This is obviously the beginning point of REST. In order to be REST level 0, you are using HTTP as a transport protocol, but you are not using it to indicate functional details of the operation. As you can see in our test case, we are using HTTP, but we are using a single endpoint. Every detail about what operation should be performed and what resource it should be performed against is based purely on the body of this HTTP request. Basically, we are just using HTTP as a dumb transport protocol. This is a common implementation strategy that has gained a fairly strong foothold in the past with architectures such as SOAP and XML RPC. Moving on to test level 1, when you reach a level 1 REST maturity, you are recognizing different resources at the HTTP level. Put simply, you have taken the single endpoint from level 0 and broken it up into multiple endpoints with each individual resource given its own endpoint. Each endpoint can and often will service multiple operations against your resource, as in the case of our individual user. This is an edit operation. The details of the operation to take against the resource are still embedded in the body of the HTTP request. The next level, level 2, introduces the concept of HTTP verbs. The HTTP protocol provides for several different methods. GET and POST are the most common, but there are also PUT, DELETE, options, and others. Level 2 in the RMM introduces the concept of leveraging these HTTP methods to indicate the operation you are taking against a given resource. By using these methods, you are also implying that you are going to use the appropriate HTTP response codes for each of these methods. So, when you post and a new resource is created, you would return a 201 created HTTP code with a location header pointing the client to where they can access the new resource. This means we no longer have to embed details about the requested operation in the body of our HTTP request. Now, the body can be dedicated towards information to be used by the operation, not information to indicate the operation. This brings us to the final level, level 3. In level 3, you are leveraging your API responses to provide the client options for what they can do next with the given resource. So, for instance, when an API request is asking for a list of entities, along with each entity, you would provide the URIs to indicate how the user can further interact with that entity. This provides for a better level of discoverability and is key to the state transfer aspect of REST. This level is synonymous with the term HATEOS, or HATEOAS. It stands for Hypermedia as the Engine of Application State. There are no firm standards for how these links should be presented. There are several different proposals and examples for how you could do it. One such proposal that you can look into if you are interested is the Hypertext Application Language, or HAL. It is worth mentioning that sometimes true RESTfulness of an API is not an important goal. For instance, if you're not going to have clients that are going to take advantage of links in your Level 3 API, and it is not an external API where your external clients could use it to discover functionality, it might not be worth the extra time to make your API a true RESTful API. If you now jump over to our user API test, you'll see how we have modeled our API to be a Level 3 truly RESTful API. We are using multiple endpoints, each with one or more HTTP methods capable of modeling our operations on the resources. We also have substantial linking from API responses to additional operations that can be carried out on the applicable resources. In this video, we took a deep dive into the world of RESTful APIs. In the next video, we will apply this concept to our user management system to create our own RESTful web service. Welcome to the second video in this section, Creating a REST Interface for User Management. In the previous section, we discussed the qualities of a RESTful API. In this video, we are going to apply those concepts to our project to create our API for managing users. First, we will go over some more details on how the Guzzle HTTP client works. Then, we will review the restfulness of our API using our API test. Finally, we will see what changes we needed to make to our existing application in order to expose a working user API. Let's get started. First, let's return to the user API test that we started exploring last video. We will look at the basic structure of this test. You will first notice that we are using our database test case trait. Just like with our Selenium tests, we will need to prepare data for our tests to work properly. In the setup function, you can see where we are setting up our Guzzle HTTP client. First, we are making sure we have a predictable hash for our comparisons throughout the test. Then we get into the Guzzle code. When creating a Guzzle client, you can specify several different options that will then apply to each request. Here, we are doing a few things. We are using the allow redirects parameter to make sure Guzzle doesn't automatically follow redirects. We want to be able to test all of our response codes, including redirects. By default, Guzzle will follow any redirects returned by the server, which would make it harder for us to determine that our pages were returning the appropriate content on redirects. We have also set HTTP errors to false for a similar reason. By default, Guzzle will throw an exception on any 400 or 500 series of response codes. While we could work with this, it is much easier to not worry about throwing exceptions, and we can just use simple assertions to test these values. Then, you'll notice we are using the auth option to specify a username and password. This will allow us to get through our authentication wall on the API. There are many ways to handle authentication in applications, but we're going to stick to basic HTTP authentication for now. The username is the first index in the auth array, and the password is the second. Finally, in order to ensure our API is using the test database when we call it, we are setting the IAM WebDriver cookie using a cookie jar and the cookies option. In the cookie jar, you can see how we specify the cookie using a domain, cookie name, and value. Now, we can use this API client to issue any number of HTTPS requests to our API using functions mirroring the various HTTP methods available. We can take a look at the various API calls we are testing against. Test listing users is testing to ensure we can return a list of users. The endpoint here is /API/users, and since we are only retrieving information, it should be a GET request. The Guzzle client offers a method for each HTTP method available. Since we are expecting content back in this request, we should see a 200 HTTP response code. The response itself should have two different sections. The first section would be to list our users. The second section would be for a list of links describing the operations we could run next on the groups of users. We have implemented this call to only return 10 users at a time, so we have added a link to indicate that pagination is involved. We are also going to allow the client to search for usernames, so that operation is listed too. We are using URI templates. This is a standard aspect of hypertext application language to indicate where a search term should go. Finally, we could add a new user to the list through the create link. You will also notice that we are specifying additional links with each one of our users. There is a self link indicating the URI to use in order to get full details about that user. There is also an edit link. The URL is the same, but this is really more so to indicate that we can use post and delete to make edits to that same user. Imagine if we had restricted permissions to where some people could only view users and not edit them. In that case, those users would not see the edit link here. The names of these links are not fully standardized, but again, you can see recommendations both with Hypertext Application Language as well as through IANA's Link Relations Guidelines. Now, moving on, our adding user functionality will leverage a POST request. The intent of the POST request in HTTP is to send information to your HTTP server, letting it determine the appropriate location for that new object. Once the object is created, the HTTP response 201 created should be returned. REST, as you have probably noticed by now, makes extensive use of built-in HTTP codes. You can find a list of these codes at Wikipedia by searching for a list of HTTP status codes. When you return a 201, you should also specify the location where the new object can be accessed. This is typically done through the location header as you see here. Again, you will also see several links out to additional operations on this resource, as well as pointing you back to a full list of resources. In the event that invalid data is used when either adding a new or editing an existing user, we should return a 400 bad data HTTP code. This code basically means that the data as sent will never be successful. In this case, that is true, because it is breaking our validation rules. You should provide messages as to why the data is bad. We can just use the same validation messages we used on the website. Editing a user uses a different endpoint that is specific to the user we are editing. In this case, we use a put request. The difference between a POST request and a put request is that with a POST request, we don't really necessarily know what the URI of the resulting resource will be. However, with a put request, we do have that information. Since we are editing a user and not adding a new one, a 201 created response is also no longer appropriate. We are going to return the new data for our user, so we can just use a 200 OK response. If you didn't want to return data, you could use a 204 no content response. This simply means that the operation requested was successful, but there is no data to return. Deleting a user is identical to editing one, except for instead of using a put request, you use a delete request. Again, you could either return a 200 OK or a 204 no content response. We are again going to use a 200 OK since we do have data in the form of links to send the user back to a list page. The final piece of our test we should look at is the onNotSuccessful test PHP Unit override. Similar to how we took screenshots on failed tests, we are using this method to capture the response from the last guzzle request and saving it to a file. Just like the screenshots, this will help significantly in trying to track down any errors that might occur. Let's tweak one of the tests so they will fail and then we can see the output. Alright, now let's check out the code that implements this REST API. We should get started in www.index.php. There has been a pretty significant amount of cleanup in this file to get rid of much of our duplicate code. We moved to using regex to determine routes, and then since the routes for each of our CRUD controllers were so similar, we were able to generate those routes from the CRUD controller. If you look at the bottom section, you will see where we define the routes for API. You will see all of our basic requests here. Underneath each subroute, you will see a list of HTTP methods supported by that route. You should take note of the extra code for our put actions. PHP does not automatically assign form-encoded data to the post array when the request method is put. We are essentially doing the same thing by reading the request body using PHP's built-in stream functionality. PHP input can essentially be seen as a file that points to the standard input for that script. The standard input for web pages is where your HTTP server will place all of the content for the body of your request. This code is essentially doing the same thing that PHP does internally when building the post array. Now, let's look at our API controller. You'll notice a few things here. Most notably, we are not using the code from our main user controller. When dealing with an API, there are many things that you should do with a normal controller that don't make sense for an API controller. Most notably, you'll see that we are not implementing CSRF protection as we don't really have forms where you could set tokens. Also, we are not using our permissions trait. Since we are authenticating through HTTP basic auth, we can't use the same session validation methods on the login. Instead, we are sending the server variables that PHP fills out with the basic auth information to our login service's attempt authentication method. Then, we added a new method to the login service to allow us to pass in the username for a permissions check. As you look at each of the action methods in our controller, you will find them to be somewhat similar to our web page controllers. There is definitely an opportunity here for more refactoring to once again get rid of duplicate code. For now, let's just take a quick peek at our new templates. As you can see, all of the templates now are just spitting out JSON code. We could feasibly put this code directly in our controllers. However, that would make it deviate a bit more from our web page controllers, which could make this all hard to refactor later. Now, as I run the unit test, you can see that we have a working API according to our tests. We can even run a manual curl command against the site and try it out ourselves. Looks good. In this video, we implemented a RESTful API to allow clients to modify users in our system. In our next video, we are going to start preparing our application to scale by moving it off of SQLite and into MySQL. Welcome to the third video in this section, moving from SQLite to MySQL. In the previous video, we added a new API to our system that allowed us to manage users. This has rounded out the functionality we are going to use in our authentication management application. In this video, we are going to begin focusing on scalability. We are going to discuss how SQLite impacts our ability to scale and why MySQL might be a better solution. Then, we will set up some accounts in MySQL for us to use while developing our database. Next, we will update our schema to reflect our change to MySQL. Then, finally, we will modify our schema update script, our test bootstrap, and our site code to leverage MySQL instead of SQLite. So, let's get started by discussing why we should move away from SQLite and towards MySQL. As you have most likely noticed by now, SQLite leverages on-disk files to handle the data that you insert into the database. This is a fundamental problem as it means in our current setup we could not just introduce a second web server and share the same data. We could feasibly get around this with a shared file system. However, then we become bound by the file-level locks that SQLite has to employ. As we get more and more web processes working against our database, the lock contentions could become significant. MySQL was built to somewhat easily handle the concurrency that you see from popular web applications. Through its InnoDB engine, it can handle both concurrent reads and writes to and from not just the same database, but from the same tables as well. Additionally, it has the ability to scale horizontally. By that, I mean you can add more than one database to your application through MySQL's replication functionality. Simply put, it is a database designed for scale. Let's get started. We'll connect to MySQL first so we can add an account for our application to use. Run the command mysql-u root-p 123. 123 is the default password that Puffpit set for our root user. Let's change that first. We can do this by running the command set password and then pass in your password as the parameter. Now, let's add a new user. We are going to run 3 commands. The first is going to give our application user access to the database. The second will be to grant access to our application database, and then the third will be to grant access to the test database. Create user auth at localhost identified by auth123. This command is creating the auth user with the password auth123. This user will only be able to connect from localhost. This is all that is necessary for us since we are running everything from our VM. However, if you need access from a separate IP address, you would also need to create additional accounts with the same name, but a different IP address such as create user auth at 192.168.%. The percent sign is used as a wildcard so you can match ranges of IPs. Now, we can run grant select, insert, update, delete, create, alter, drop, index on auth.star to auth at localhost. Now we can do the same for the auth test database. This is granting all privileges required for our application users. You can check out the MySQL documentation at dev.mysql.com to understand more about the grants and privileges system. Alright, Let's log out of the root user now and log in as the auth user. To keep your password hidden, do not pass a parameter to -p. Then it will ask you to enter one like this. Awesome. Alright, now let's review some of the changes we have to make to our schema. While MySQL and SQLite are both SQL databases, they each use slightly different flavors of SQL. We will want to make some changes in our schema file to make it more compatible with these slight variations. One difference from the syntax perspective that is going to affect us with MySQL is that it will not explicitly set columns to auto-increment like SQLite does. So we just need to make sure we add the keyword auto_increment to the end of all of our primary keys. Another difference is that MySQL allows for varchar columns where you can specify maximum lengths. This helps make index performance a bit more predictable. So we should convert the text fields to varchar and set the maximum length to 100. This is done by placing the 100 in parentheses at the end of the varchar type. We should keep our column lengths in sync with what our validation rules are where possible. So we should make sure to tweak the username column to 50 and the email column we will change to 255. While the email column doesn't have a length limit, 255 characters should be enough. Alright, now let's look at our new update schema script. We need to modify it so we can update our new MySQL schema now instead of our SQLite schema. We will just use PDO to open a connection to our database server. Then we can use the commands drop database if exists auth, create database auth, and use auth. These commands will destroy the database if it exists, and then recreate an empty database, and finally set the MySQL connection to use that database. Finally, we just run all of the commands that are also in our schema.sql file. If you look at test-bootstrap.php, we are basically doing the same thing here as well. Then, we have modified the database test case trait to allow us to inject the PDO object for all of our test cases. Now, we do need to make some changes to our code in order for us to switch to MySQL. Thankfully, since we consolidated most of our database work into the simple CRUD repository, this is really the only class we need to change. The first area we need to change is save entity. It turns out that MySQL is significantly less forgiving on extra PDO parameters. Since getRow from entity was returning both associative and numeric indexes, the MySQL driver for PDO errors out because we pass more parameters to execute than we did have tokens in our query. This is easy to fix by simply building our parameter list as we build the placeholder list. The second change we need to make is also where we detect the duplicate entity exception. MySQL has a different message that it displays for this error. Unfortunately, it does not tell you the column that had this issue. It only displays the index name. However, if we format our unique indexes in a consistent manner, like we have here, we can still use our regular expression to capture the portion of the index name. These two errors were relatively easy to find. All we needed to do is run our test suites, and the errors would make themselves very evident. The last thing we need to change is our PHP configuration in Bootstrap. We just need to swap out the database file for our production and test databases with the appropriate database name. Then we can change the PDO parameters to no longer be a SQLite DSN, but a MySQL DSN with a username and password. Now that we have fixed them, let's run all of our test suites. We will start with our unit tests. They pass. Now let's try our functional API tests. Great, they are passing too. Now let's start Selenium, and we can run our functional web tests. They pass. Well done. In this video, with just a handful of changes to 6 files, we were able to convert our application from using SQLite to using MySQL. This was all made possible and pretty easy by the refactoring and testing we have done up to this point. In the next video, we are going to take care of moving sessions off of our file system and into our database. Welcome to the 4th video of this section, moving sessions from files to the database. In the previous video, we got rid of a dependency on local SQLite files and instead built a dependency on a database that we could freely move around our network. In this video, we are going to focus on doing the same thing with our sessions. First, we will create a new table for our sessions. Then we will implement a new session handler using PHP's session handler interface. Finally, we will integrate our new session handler into our code. You may remember from way back in Section 2 that PHP by default stores sessions in the file system. While this is great for rapid prototyping and getting projects off the ground quickly, as we learned in the last video, these file system operations can introduce significant bottlenecks. We need to get these sessions moved into the database. That way, we can be confident in being able to handle a single session from multiple load balance servers when we get to the point of needing to scale out our application. Thankfully, PHP has made it very easy to extend their session functionality. Before we do that though, let's focus on creating the table to store our new session data to. Head over to schema.sql. Towards the bottom of the file, you should see a new table called Session. For our session, we need to store a few things. We need the ID, we need an understanding of when we should expire the session, and we need a place to store the session data. Session ID should always be unique to an individual user, so we can reflect that here by making it the primary key. Then, we will need to do garbage collection every now and then to keep our session table from growing too large. These deletes will always be based on what has expired, so we should add an index to expiration as well to make sure we can delete those old sessions efficiently. Great! So now we should be able to rebuild our production database. Now, we need to create our custom session handler. Thankfully, PHP has made this quite simple by providing an interface that you can implement to create your own session handler. This interface is called Session Handler Interface and is documented in the PHP manual under the same name. We have our own implementation of this interface called Database Session Handler. Let's open that class and take a look. It has a single dependency on an existing PDO object. We will use the same database connection for our sessions as we do for our other application data. So when a user first calls session start, the first thing that happens is that the open method is called. Typically, this will be used to either reinitialize a session or to create a new one. We can wait until we have data to write before we add any rows, so for now we can just return true. After PHP calls our open method, it will call the read method. This method should find the data for the given session ID and return it. PHP works with its session handlers using encoded strings. These strings are basically outputs from the serialize method, nothing too fancy. One aspect of sessions you should always be aware of is that you should have some sort of locking mechanism in place to make sure you don't have race conditions with two different requests operating on the same session. The first temptation for this with database sessions is to use transactions. The problem with this, however, is any locks you obtain cannot be released until after your session is closed. That means all other queries on our connection would also be inside of that transaction. Depending on your application, this could be okay. However, sometimes it may not be. Consider if we had an issue saving the session. Then the entire transaction would be rolled back. This means any changes to your user worked on in that request would have to be redone. This could cause quite a bit of frustration. To get around this locking problem, I am using application-level locks in MySQL. These are locks that you can obtain outside of transactions and are really just advisory locks. They won't prohibit you from making changes to any tables, but as long as all code modifying a row in the session table uses the same lock, you will be just fine. The get lock call above will block if the lock on that given session has already been obtained. It will not, however, block for any more than 60 seconds. So, if you have a runaway process, your user won't be completely stuck. Now, we can read the data from the session. We simply query it by session ID, and if we are able to retrieve a row, we do one more check to ensure that the session shouldn't be marked as expired. If all is well, we return the data. If the session expired or just doesn't exist yet, we simply return an empty string, and PHP will treat it like a new session. Once we are done with a session, PHP will call the write method. This method takes a session ID and an encoded string containing our session data. We simply attempt to insert this data into the table. If the session already exists, then using onDuplicateKey update in MySQL, we can modify the data and update the expiration time. In order to set the expiration of the session, we are observing the GC_max lifetime INI setting. You don't have to do this, but it does make life a little bit easier as it makes the behavior of your sessions somewhat predictable based on PHP's own session parameters. Continuing on to the close method, you can see where we are releasing our lock. Also, if PHP has determined that garbage collection is necessary, we do it here. PHP indicates garbage collection should be run by calling the GC method. We don't perform the garbage collection right away here, as we can release a lock on the session sooner if we wait until the close method. The final method is destroy. If we tell PHP to destroy a session, this is the method that gets called. As you can see, it simply issues a delete against the session table for the session in question. So, now that we understand how our session handler works, how do we enable it? Well, that is simple too. Let's go to bootstrap.php. You can see at the bottom of this file, we have instantiated our handler and passed it our PDO connection. Then, we just call session set save handler. That's all there is to it. Let's give it a quick try. Go ahead and head over to your browser and view auth.dev. Log in using admin/admin. Now, we can go to our terminal and type in mysql-u auth-p -e select star from session auth. There's our session. Great job! In this video, we moved away from our file-based sessions and have started using the database to store sessions. In the next video, we are going to look how we can leverage Memcache to decrease the load on our database and increase our scalability. Welcome to the fifth and final video of this section, Introducing Memcache for Caching and Session Management. In the previous video, we learned how we could create a database-backed session handler. In this video, we are going to learn how we can leverage caching to alleviate load on our database. First, we will go over some environment changes we need to make in order to use Memcache. Then, we will create a new service that we can use to store data into and retrieve data out of Memcache. Next, we will integrate this new service into our base repository. So when originally developing the content for this video, the plan was to use the memcached library. Of the two Memcache libraries in PHP, it is the more recently developed library, and it seemed to get more recommendations. However, when testing the library, I discovered that it would relatively frequently hang and not return data. The great thing about it is that our feature test suite is what showed that the library had problems. So yet again, our test suite saves our bacon. I know that there are several people out there that use the memcached library with success. So don't discount it simply because of this video. However, instead of memcached, we are going to use Memcache. It doesn't exhibit the same issues with our code as memcached, and while it may not be as feature-rich, it does have the functionality we need. So, in order to use this library, we do need to make a small tweak to our puffpit config. Open config.yaml in the puffpit directory, and make sure you add the memcache extension. It is okay to leave the memcached extension, or you could also remove it. Since both Memcache and MySQL take a decent amount of memory, increase your memory limit to 1024 if you have room. After you make the changes, be sure to run a vagrant reload -- provision. This will restart your box so you get the extra memory, as well as rerun provision to make sure Memcache is installed. Great! Now let's look at our Memcache service. Similarly to our database service, we should create a service wrapper around Memcache. This time, however, I'm going to take our abstraction one level further. If you look at our Memcache server, it does not provide any access to the Memcache object at all. Any operations we need to run against Memcache are implemented directly on the Memcache service. This will allow us at a later time to fairly easily replace Memcache with memcached while only having to modify methods in this class. If you are not familiar with Memcache, it is a very quick, easy-to-scale caching service. You are able to store data in as key-value pairs. The Memcache extension provides an easy-to-use object-oriented API to this service. You are able to run multiple Memcache servers, and the client handles ensuring your data is distributed across all of those servers. Similar to a database, there are operations to read, insert, update, and delete keys. There are also other operations such as incrementing a key as a counter or using a compare and swap operation. A very common strategy in enterprise and non-enterprise systems alike is to use something like Memcache to offload overhead from the database. The way Memcache is designed is that it only stores data in memory. While this means accessing the data in Memcache is quick, it also means that it's very volatile. If the server goes down, so does the data. So you usually would not want to replace your database. However, you can use it to reduce the number of reads you make to your database. In our system, we have implemented something called namespacing. Because Memcache is a simple key value store, you have to understand the precise name of keys for operations. There is no hierarchy unless you implement it yourself. A case where we would want some sort of hierarchy is in understanding when we need to expire data in the cache. For instance, if I edit a user, I want to make sure any cached references to that user are expired. This includes not just a cache key containing the single user, but really any cache key containing a list of users could also be affected. It would be incredibly difficult to keep track of all of the affected keys on the fly. This is the purpose of a namespace. You will see in our ns_set method, we accept a namespace, a key, a value, and a TTL. Using the namespace, we retrieve an identifier for that namespace from Memcache. Then, we use the returned identifier as a part of the actual key we set in Memcache. We pass in the value and set it to expire after TTL seconds. So, if TTL is set to 60, this value could be retrieved from our Memcache server for the next minute. Now, in the ns_get method, you can see we again retrieve the namespace ID, and then we build the same key and pull the data for that key out of Memcache. So, how does this help allow us to expire all of the keys for a user? Take a look at the next method, ns_flush. It also takes a namespace, but here you can see the magic. When you call ns_flush, we increment our namespace ID or set it to 1 if it didn't exist. While this doesn't delete the namespace, it does cause all of the actual keys you would use to read and store the data to change. So say I had been storing users in my user namespace. Before I call flush, the underlying key for my user list would be something like auth_ns_users_0_user list. After flush, however, the 0 changes to a 1 and the key is different. This key would initially be empty, causing me to retrieve the new data from the database. With a system like this and some cleverness in what namespaces you use, you can really improve the efficiency of your caching. While you aren't actually deleting any information from Memcache, when Memcache gets full, it will always delete the least recently used keys. This means that eventually your old namespace keys will just naturally fall off. You may have also noticed us using a prefix for our keys. This is done specifically to make sure that, similar to our database connections for test versus production, we have a separate Memcache namespace for tests versus production. Alright, so how do we integrate this with one of our classes? Let's take a look at the simple CRUD repository. If you look at getSortedList, you will see a few changes. The first thing we do now is check Memcache for our list. We are embedding our limit and offset values from the parameter list into our key to ensure that we don't mix up our cache data between requests. If Memcache is able to find that key, it will contain the entities that we would have otherwise generated from the database. You can see a little further down in this method where we set that same key. If Memcache can't find the key, then it returns false. So after calling ns_get, we check the return value. If it returns false, we continue loading the data from the database. Otherwise, we can immediately return our data. Notice that all of these calls are just using the table name as the namespace. The last thing you'll notice is that I'm no longer using a generator. Since I want to be able to cache all of the data, a generator no longer makes sense. I'm not ready to change the signature of my method quite yet though, so I do still wrap it in an array iterator for now. This is something we could refactor out later and just use raw arrays. Now, if you go down to some of our modification functions like save entity, you can see that immediately after we issue modifying queries, we flush our namespace as indicated by the table name. It is as simple as that. Now, for testing with Memcache, you really have to have a similar concern with Memcache as you do with the database. You need it to start in a known state. Thankfully, that known state can simply be empty. Take a quick peek at our group management test. You'll see that in setup page, we will call full flush. This delegates out to the Memcache flush method, which essentially invalidates all of the keys on your server. Alright, one last change I want to make. Both Memcache and Memcached come with their own session handlers. Remember that session handler we created for the database? Now we are going to get rid of it. Open up bootstrap.php and you can see we have replaced our previous calls with ini calls to set the save handler to memcache and the save path to our memcache server location. With just that change, we are now using memcache for sessions. It is worth noting that depending on your situation, memcache may not work well for sessions. Again, since memcache holds everything in memory, it is very volatile. It works well as a caching layer because it is never the source of truth. If the data is not in memcache, you can always go to that source. However, when you use it as a session handler, you are saying that memcache is the source for sessions. This may work well for you, but in practice, it generally is not the best idea. If your memcache server shuts down, you will permanently lose all of your session data. Alright, let's browse around a bit and see how the site works. It looks great. It is still working well. Feel free to run the unit tests, feature tests, and API tests too. In this video, we added a layer of caching to help ensure we could handle additional requests without stressing out our database. In this section, we learned how to allow our application to be used as a web service and several techniques on how we can allow that service to scale. We reviewed what it meant to be a REST service. Then we walked through how we could convert our existing app into a RESTful web service. Next, we shifted our focus to scalability and got rid of a few of our possible performance bottlenecks by replacing our SQLite server with MySQL and also using MySQL for our session storage. Finally, we gave ourselves some more performance cushion in our database by adding a caching layer using memcache. In the next section, we are going to learn how we can take an existing third-party framework called Silex and expand on it to build a social sharing platform. Welcome to the 7th section of PHP Projects Creating a Social Sharing Platform. In the previous 2 sections, we worked on creating an authentication management platform from the ground up. In this section, we are going to learn how we can use third-party libraries and frameworks to speed up development of a new social sharing platform. First, we will take a quick overview of the Silex framework, a micro-framework that makes it easy to put together bits and pieces of other frameworks into your own application. Then, we will look at how we can use a third-party Silex OAuth provider to quickly enable using Google to log into our system. Next, we will augment that login process to allow us to store data for our logged-in users. After that, we will dig into how we can use Silex to create a simple service to pull data from a page, and then using this service, we will enable an interface for our users to share URLs for others. Next, we will look at how we can allow our URL crawling service to scale using a job queue. Finally, we will see how we can use long polling to communicate new URLs to active users. In this video, we are going to really focus on the basics of Silex. First, we will go over code locations and how to get set up with the project. Then we will take a look at what composer packages we need to install to use Silex. Finally, we will take a quick peek at a simple implementation showing a page with a counter and a login button. Let's get started. Before we begin, it is worth noting that you can find all of the code for the next 2 sections on github.com/phpprojectsvideo/socialdev. On this GitHub page is a README file that provides instructions for setting up the VM, the code, and modifications to your etc hosts file. Just like our last sections, we have also created a tag in the repository for each video. That should make it easier for you to follow along. Alright, let's jump into the code. Let's start by looking at composer.json. You'll see that we are loading 3 new libraries, Silex, Twig, and Doctrine Debal. Silex is a PHP micro-framework that we are going to use to help organize our project. As a micro-framework, it does not really force you into a particular way of doing anything. At its core, it is just a routing framework that allows you to bind code to a particular URL. However, using Silex providers, we can start adding on to this behavior to provide things such as sessions, validation, templating, and more. We are going to cover many of the features of Silex over the next 2 sections, but I would recommend that you take some time to look through their documentation to learn all of the different providers you can use, as they save you a significant amount of time. One of the providers in Silex is a Twig provider. This allows us to use Twig templates in order to display views in Silex. Twig is a powerful templating engine that helps with separating the display and interface of your application from the back-end business logic. This templating engine provides many of the same control structures like if statements and for loops, as well as variable escaping and filtering that we used with PHP templates. You don't strictly need to use a templating engine like Twig. However, it does provide for a much more template-centric API when you look at inheritance, variable escaping, and more. The final library we are integrating is Doctrine. It is a database abstraction layer similar to PDO, but again with some added bells and whistles. You'll see in this video that for now we are just using it to provide support for database-backed sessions. Alright, let's check out our project quickly before we go further into the code. Go to social.dev. For now, this is a simple page with a login button that really doesn't do too much. If I start refreshing the page, however, you will notice a counter that is incrementing with each refresh. Let's see how this basic page works. Open www.index.php. This is our silex endpoint. All calls to our site will go through this file, similar to how our previous project worked. The first thing that we do is create a silex application object. The application object acts as both an object container as well as our front controller for the entire application. It is really the nerve center of our application. Every action taken will go through this object. After we instantiate our application, we use the register method to register a few different service providers. Each one of these providers accepts a configuration array that helps establish the behavior of the provider. These configurations are typically documented for each provider in the silex documentation. After registering a provider, several new objects are typically created and added to the application container. You can see an example of this in the session provider where we make a reference to app.db. This object was added by the Doctrine service provider. Again, the objects provided are also documented in the silex documentation. You can get an understanding of how these objects get created by again looking at the session service provider. You can see for the session storage handler configuration, we are specifying a closure that references our app. Now, the first time we reference app session storage handler, this closure is executed and the return value is passed through and reused every future time we call app session storage handler. This concept provides a powerful implementation of dependency injection. It helps make sure we can define objects easily, but also keeps us from wasting resources if there are requests where we don't need those objects. Alright, moving on down you will see where we have defined our first route. The app object contains methods that correspond to each of the various HTTP methods such as post or get. The first parameter for these methods is a string that matches one of your URL paths. The second parameter is then a closure that will execute when that path is visited. So, when we visit social.dev, this method is executed. The return value is then a response object that is used to either display data to the browser or maybe redirect the browser to another URL. In our router action, we are using the session object that was added to our app by the session service provider to store a counter that we increment and write back with each request. Then, you will see that we are using the Twig object to render our index.html.twig template. The second parameter to render specifies the variables we are making available to that template. Finally, we call app run, which checks and executes our controller actions. Now, if you open up index.html.twig, you can check out our template. Twig uses block-based inheritance similar to what we implemented in our last project. If you go to base.html.twig, you will see a simple template with a single body block. In index.html.twig, we override that body block with our HTML for the home page. All control structures in Twig use the curly brace and % tags. Anytime you see this, it is an indication that Twig will be performing some sort of logical step. In many ways, it is easier to use than basic PHP templates we have used to this point. Twig variables or methods are printed to the screen using double curly braces. It is important to know that with Twig, any output variable is automatically escaped. So if you have a variable that you intend to contain HTML, you can use a pipe operator and add a raw filter. Twig provides many filters, tags, and operations that are all very well documented on the Twig website. So every time we visit social.dev, the app run method triggers, which executes our action method. Our action method then sets up our variables and passes them to the twig template and returns the resulting template as a response. In this video, we have set up a very basic beginning to a project using Silex. In the next video, we are going to use a third-party Silex provider to allow logging into our platform using Google. Welcome to the second video of this section, using OAuth to log in. In the previous video, we set up a simple Silex project and created our first template. In this video, we are going to see how we can use a third-party OAuth provider for Silex to use Google to log into our site. First, we will install the new packages necessary for us to implement OAuth. Then, we will review the providers we must add to our application. Next, we will take a look at the changes we must make to our routes and our templates. Finally, we will set up a new project in Google's API console to allow us to leverage their login platform. So let's start by taking a look at composer.json. We have added two new packages, security and silex-OAuth. The first library enables Silex's built-in security provider. This provider allows for us to define sections of the site that require certain levels of authentication, as well as the behavior we should take when a user attempts to access a part of the site that requires special privileges. This is similar to the login functionality we implemented in our last project. This just does most of the grunt work for you, leaving you to really define just how user accounts are located. The second library, silex-OAuth, is a third-party provider that adds OAuth functionality for authentication into the Silex security provider. So instead of gathering login information from a form, this library allows us to hook into an OAuth workflow so we can validate credentials from another site such as Google, Facebook, or Twitter. Using these two libraries, we should be able to very easily implement authentication to our site using Google's OpenID platform. Now, let's head on over to index.php and see how we configure our new providers. You'll notice that the first provider is a CSRF provider. Silex has CSRF functionality built in. This provider is used by our OAuth provider to generate CSRF tokens for logging out. We will also use this functionality later to ensure that we are adequately protecting other form submissions from our users. In addition to registering the provider, we are also copying CSRF Token Manager to form.csrf provider. This is made necessary by the OAuth service provider below. The Silex CSRF provider recently changed where in the container the token manager is stored. However, the third-party OAuth provider hasn't been changed to match yet. This allows us to get around that. We are configuring our OAuth provider to use Google for login. The Silex provider builds on top of Lusitanian's PHP OAuth lib, which has support for many popular OpenAuth-enabled sites. For the most part, configuration of each service is nearly identical. For Google, I am using constants to feed in my client ID and secret. If you scroll up to the top of this file, you will see we are now including a config.php file. If you open that file, you will see a check that ensures those two constants are defined. The client secret is a special value that really shouldn't be shared, so we will keep that in a local configuration file that doesn't get committed via Git. It is in our git ignore file. In this file, we simply define these two keys. As you can see, the keys here are currently blank. We will fix that soon. Now go back to index.php and you'll see that in the scope key, we are asking for access to email and profile. When a new user first logs into our site using Google, they will be asked for permission to use these two pieces of information when we log in. Finally, the user endpoint is used to return details about the user that just logged in. We can use this to pull things like names and email addresses. The next provider is the security service provider. Again, this provider is what triggers OAuth when a user attempts to log in. In the firewall section, we have set a default access that allows anonymous users access to most URLs. The OAuth setting is telling our OAuth provider where to send and what to listen to for users that need to interact with specific login services such as Google. Similarly, we can specify where to go for logout. When these URLs are visited, the OAuth and security providers will intercept those actions, so we don't need to define these routes ourselves. The user key defines a provider for user data. Typically, when a user logs in, you want access to information of that user to help with the displaying of data on the site. This class would be responsible for returning the proper information. We will learn more about this in the next video when we talk about completing a registration process. App before is a special method that we haven't talked about yet. This method allows us to take special actions before any route is handled. Here, we are using the security token storage and security service to find our login token for the user. Then we can check to make sure that token identifies someone, and we can add the user and a few OAuth path locations to our app for use later on in routes and templates. The login paths will contain an array of URLs that we can use to log our users in via Google, Facebook, etc. The logout path will contain the URL required to log a user out of the system. Then you can see in our homepage route, we removed the unnecessary counter code and instead added a new error template variable. This variable will be populated if there was an error specified by the OAuth provider when the user logged in. The logout route you see here is largely unnecessary. The main reason we have it is so we can take advantage of the bind method. The bind method allows you to give a name to any route. This name can then be used in the URL generator to create your URL. So if I chose to move a page to a different URL, I could update the URL for the route, and the URL generator would then generate the proper URL based on my route name. You can see that we use this route to generate our logout URL. Now let's take a quick peek at our template changes. We are checking to see if our user is logged in and then returning some information about that user along with a logout button. If the user is not logged in yet, we are presenting them with a login button pointing at the Google login path. Now let's check it out real quick. You'll see as soon as we try to log in, we are getting an invalid request error. This is because we are missing our client ID. We need to generate these values through Google. You will need a Google account for the next part of this video. Using that Google account, log in to the Google Developers Console at console.developers.google.com. From here, you can either select an existing project or create a new project. You will be asked for a project name, and if you haven't been asked, you will also need to review the terms of service. Go ahead and do that and then click Create. Now go to Credentials and then the OAuth consent screen. Here, you need to choose an email address and add a product name that you can show to users. I just use Social Dev. Now, go into the Credentials screen. I already have created a client ID, but if you do not have one already, you can click on Create Credentials to create an OAuth client ID. Choose Web Application, give your application a name, and then you will need to add social.dev/auth/google/callback as a redirect URI. This name corresponds with the callback path we added to the OAuth provider. While it is not strictly necessary, you could also add social.dev to your authorized JavaScript origins. Now click on Create. All you need to do is copy this ID and secret into your config.local and you are ready to go. Let's give it a shot. I'll log in with my user account. There we go. We are in. Great job. In this video, we added the ability to authenticate with our site using Google logins. In the next video, we will extend this functionality into a registration workflow for new users. Welcome to the third video of this section, completing the account registration and login flow. In the previous video, we integrated Google's authentication platform into our site using OAuth. In this video, we are going to look at how we can combine our own user data with the users created by Google Authentication. We will first see what our user entity is going to look like. Then we will see how we can use Doctrine to map our entity to a SQL table. Next, we will set up a form in Silex to allow our users to save data to their profile. Finally, we will see how everything gets tied together in our routes. To set up our entities, we are going to use Doctrine's Object Relational Mapper, or ORM. An ORM framework such as Doctrine allows you to map entities to database tables to make it easier to populate and persist entities from and to the database. Using Doctrine will save us much of the time spent in the earlier project in setting up our repositories. In order to use Doctrine, we need to include a few packages from Composer. The most important ones are Doctrine ORM Service Provider, Saxilum Doctrine ORM Manager Registry Provider, and Doctrine Bridge. These packages combined give you the providers necessary to be able to use Doctrine's ORM framework within our Silex application. If you take a look at index.php, you'll see that we are no longer using the application object. We have created our own social application class. If you click through, you will see that we have moved all of our register calls into this class's constructor. That will allow us to use our application object in multiple files without having to copy all of our provider configuration every time. If you check out the new providers, you will see our Doctrine ORM service provider. You can read more about how to configure this provider from the dflydev Doctrine ORM service provider page on GitHub. In the source directory, we have created a model directory and a user directory. You'll notice that our user entity is implementing user interface. In order to tie our internal user data to our authentication data, we are going to leverage Silex's security provider. They provide this user interface, which defines methods to indicate your user's role, password, salt, username, and also provides a way to erase credentials if necessary. You can read more about how the security provider works in Silex's documentation. Looking at the properties of the user, our user ID will be generated by our own database. The Google UID and email will be provided by Google, and usernames will be a field we ask our users to fill out. Continuing down, you'll see some basic setters and getters, and then you get to our user interface methods. We are not going to get too deep into roles in this series, but basically, if you are logged in, you are a user. Since we are using OAuth for authentication, we really don't need to handle passwords, so we can just return an empty string for both the password and a null string for the salt. We can also leave erase credentials as a null operation. This would typically be used to clear out a clear text password from your object once a hashed password has been generated. IsFullyRegistered will be used to help us differentiate between users that have finished our internal registration process versus those who have not. Then the final method is a static method that is used to integrate with Silex's validation provider. You can read more about validation in Silex's documentation for the validation provider. Silex uses the same validation component as Symfony, so Symfony's validation documentation is a good read as well. This static method allows us to pass our user entity to the validator. When this is done, the validator will check to make sure that we are using a unique username containing valid characters and isn't blank. In order to use our user entity with our security provider, we need to create what is called a user provider. Open Social Dev User Provider. This class is implementing OAuth User Provider Interface and User Provider Interface. These interfaces define the methods needed to load the proper user class for your security system. If you look at Load User by OAuth Credentials, we can see how we are using the ER variable, a Doctrine entity repository to load our user entity using the token provided by Google. If a user can't be found, then we create a new object and use Doctrine's Entity Manager to mark the user for persistence. Then we call flush. At this point, the user is actually inserted into the database. So, how does our Social Dev User Provider get the Entity Repository and Manager? Go back to our social application and find the Security Service Provider. We replaced the original in-memory provider with our new class. Here, we are able to pass in our Entity Manager and the repository that we will use to retrieve user entities. Now let's see how the user entity gets mapped to a table. In the Models directory is a Mappings directory. This directory is configured in our Doctrine ORM provider. In this directory is a YAML file that contains mappings for the user entity. Inside of this file, you can see how we map our entity to the user table. For instance, we are storing the ID in the user ID column and mapping it to a property of the same name, and the Google UID property is mapped to the Google UID column. You can also specify SQL details such as if the column is nullable, the column type, and whether or not it's unique. The Doctrine ORM documentation contains details about the different mapping options you have. Now that we have a mapping file, we can use vendor bin doctrine to generate proxies and schema, among other things. Run vendor bin doctrine and you'll see a list of commands. Let's check out the schema tool. Run vendor/bin/doctrine ORM schema tool create and then dump SQL. You can see the SQL generated from our mapping file. You can also run ORM schema tool update as an alternative to completely wiping out your database. This just runs alter statements necessary to update your schema without necessarily losing any data. Now let's quickly take a look at how forms work. In index.php, let's focus on the register route. You'll see we are now using a form method on our app. This method is provided by the form trait that we've added to our application class. This is creating a form using the silex form provider. The form is being defined by our registration form type class. You can find this class in the UI form types directory. In this class, we are building a form with a single required text field for a username. We are passing in the user entity as the data backing the form. So when we check for the username value in the form, it is going to map to the username field on our entity. You'll notice in our route action, we have defined a request parameter. If you have a parameter in your action that is type hinted to request, it will automatically be populated with a request object containing details such as the query string parameters. This request object can be passed to our form's handleRequest method to populate our user entity with data from the request. Then we can use the isValid method to make sure that the form was valid. If it is, we pull the data back out, and using our entity manager, we can persist and flush the entity to save it to the database. Then we will redirect the user to our home page. If the form is not valid, we will render the form. The createView method on form creates a form view object that we can use in our template to automatically display our form fields. If you look in our auth/register.html.twig template, you can see where we pass the form object to form errors and form widget to display our form. You can learn more about forms from Silex's documentation for the form provider. Let's see how our new form works. Log in if you haven't already, and then go to /register. You can fill in your username, and now you should see the username at the upper right-hand corner of the screen change. Great job! In this video, we learned how to use Doctrine and forms to augment our registration data. In the next video, we will see how we can leverage silex to build a service that allows us to crawl URLs for metadata. Welcome to the fourth video of this section, Creating a Crawler Service. In the previous video, we rounded out our user account creation process. In this video, we are going to focus on how we can create a service that loads metadata for URLs that are shared. First, we will see how we can use a library called Goot to crawl a web page and retrieve data about that web page. Then we will see how we can create our own silex service provider to give our application access to this service. Finally, we will see how we can use silex to create a simple command line script. Let's start out by taking a look at Goot. Goot is a web crawler library that allows us to interpret and navigate web pages. It is in many ways similar to Selenium, but instead of controlling a real browser, it is simply using curl to process the requests and retrieve pages. In the model directory is a new URL directory. We are going to create a command line script that we can pass a URL to. It will in turn look up some basic information about that URL and save it to our database. Let's start this time by taking a look at our URL entity class. For the most part, this is a very simple class. It contains properties for the URL ID, URL, title, description, keywords, and an image URL. It also has a method to generate a URL hash. We want to make sure that our URLs in this table are unique. However, with how long URLs could be, that doesn't make for a very friendly lookup, so we are going to use the hash of the URL as an ID. You can see how we are hashing in Generate URL Hash. Alright, now let's look at HTTP URL service. This is the service responsible for crawling a URL and obtaining data about the URL using the HTML at the URL. You can see in the constructor where we are passing in our Goot client. The bulk of the work is done in getURLEntity from URL. This method accepts a URL entity that it will then populate with information received from the crawl. You can see we start out by making a GET request to the URL in the entity. Then, we call a private method getURLMetadata. This method returns a large associative array containing keys for various meta tags, link tags, and title tags. We then run through a series of waterfall conditions on the return keys to find the appropriate image URL, title, description, and keywords to store. For instance, For an image URL, we first look at some open graph parameters, then if we couldn't find one of those parameters, we look for Twitter's image meta tag. So now we can pass a URL entity to the service, and when the method is complete, that object will be fully populated. So how do we use this service in our application? Take a look at URL Service Provider. You can create your own silex providers by implementing Service Provider Interface. This interface defines the register method, which accepts a container object. Our social application object is an extension of container and is what eventually gets passed to this method. Similarly to how you can retrieve objects from the container, you can also save objects. If you save a closure, then when someone attempts to retrieve that object, the closure is ran and then the object is returned. So if no one ever calls app URL GUT client, a GUT client would never be instantiated. You can see here we are adding our new service to our container using the key url.http URL service. Alright, let's take a look at our command line script. In the social.dev/bin folder is a new script, fetchURLData.php. Open it up and take a look. You can see we are instantiating social application just like we do in index.php. However, we obviously don't need to provide routes, and we also don't call the run method since we don't have an HTTP request to process. Instead, we call boot. This handles some bookkeeping for the silex application and should be used when you want to use silex but don't want to use it for HTTP requests. Moving on, you can see that we are using Doctrine to get our URL entity repository. Then we are calling a custom method on that repository. Typically, all Doctrine repositories are direct instantiations of a Doctrine class called Entity Repository. However, in your mapping file, you can specify a custom repository class. Let's take a quick peek at what our getOneByURL method looks like. Here, we are accepting a URL string. Then we are creating a hash of that URL, and then the find method on Entity Repository will load that entity by the ID column. If you look at our URL's mapping file, then you can see that the URL ID field holds our ID. If you remember our URL entities constructor, we do the same conversion there as well. So this is a simple method that just makes it very easy for us to load URL entities by the string URL. In fetchURLData, if our URL entity doesn't exist, then we create a new one with the passed-in URL and persist it. We don't flush it yet because we want to wait until we have retrieved more data. Now you can see where we pass our entity to our HTTP service. Then we finally call flush to save all of the data to the database. You'll notice that if we use our repository to return an entity, we don't ever call persist. Really, all the persist method does is allow the entity manager to track that object. Any entity returned from a repository is automatically tracked. Alright, let's run our tool against a URL from dzone. Now that it has run, let's browse our database and see what the data looks like. It's all there. In this video, we created a command line service that crawls a URL for data and saves it in our database. In the next video, we are going to move that service into our site and allow it to be triggered from a user-submitted form. Welcome to the fifth video of this section, allowing URLs to be shared. In the previous video, we created a service that populated a URL entity with data about that URL and exposed it as a command line application. In this video, we are going to trigger that service from a form. First, we will add a new table, entity, and repository to represent liked URLs that link to a URL and a user. Then we will see how we can create a page that forces a user to log in. Finally, we will add a form for liking a URL to the site and integrate it with our HTTP URL service. To store our liked URLs, we are going to create a new table called liked URL. It can be used to link a user to a URL that the user likes. Open the like URL mapping file. You'll notice now that we are using the many-to-one field in the YAML file to indicate that we are going to be joining two entities together. For example, the user property on the linked URL entity is going to be pointing to a user entity object. That object can be loaded and saved by referencing the user ID column in the user table and joining it to the user ID column in our table. We are also adding a unique constraint to the database to ensure that a user doesn't like the same URL more than once. Now, if you open the LikeURL entity class in LikeURL, you'll see that it is a very simple entity. It does have a validator metadata method. We will use this to ensure at the application level that we are not adding the same URL multiple times later on when we implement the form. We will also create a custom repository so we are able to easily load the 10 most recently liked URLs. This will make it a little bit easier to show our liked URLs on our user page later on. You can see here that we are using the findBy method on the entity repository. The findBy method will allow you to return multiple rows, sorted, matching a particular criteria. In this case, we are looking for up to 10 URLs belonging to the passed-in user, sorted by their timestamp in descending order. Because liking a URL is something that really only a user is going to be involved in doing, it makes a lot of sense to let our user entity be a factory for liked URL entities. Let's take a look at user entity. If you scroll down, you will see that we now have a liked URL method that accepts a URL entity and returns a liked URL entity. It will also set the timestamp for the liked URL entity for the current time. This will allow our code in the router action to be much more expressive about what is actually going on. Now let's get our router action set up. Because we need a user to be able to like a URL, we should make sure that our new route requires the user to log in. This can be done from within our security provider configuration. Open socialapplication.php. In the security service provider, there is a security access rules configuration. Here, we can map path regular expressions to roles that are allowed to access that URL. We have specified that our auth URLs, register URLs, and user directory all require the current user to have the role user role. If you remember from our user entity, that is what our getRoles method returns. Now we can look at our router. You will see that we have added 2 new routes, a user homepage and a page to handle URL liking. In our homepage, we are creating a new form to handle our URL. If you click through to this form, you will see that it just has a single URL field. You'll notice that unlike our user form, we have placed our form validation constraints in this file. Go back to our router and you will see that in both of our new pages, we are just using an array to populate this form. We could have also bound this form to our URL entity, but I wanted to make sure you could see both examples. You can also see now where we are using our liked URL repository to pull a list of the active users' liked URLs from the home page. In the like URL router action, you can see the familiar code to set up and validate our form. Then you can see where we load our URL. If the URL doesn't exist, we create it and send it to our HTTP URL service to populate the metadata. Finally, we use our new LikeURL method on the user to create our new liked URL entity. We pass it to our validator to make sure it is unique, and then, if it is, we persist it and flush. Then we redirect the user back to their home page. If the form is not valid or hasn't been submitted, we will display the liked URL template. Now, let's take a quick look at our new user homepage template. Open view/user/index.html.twig. If you scroll down, you can see us checking for the length of our liked URLs array using the length filter. Then, we use a for twig tag to iterate over the list of liked URLs. This is very similar to PHP's for each. For every item in the liked URLs array, we will assign each item liked URL and execute the template. You'll notice then where we are making calls to the properties on liked URL. When referencing either methods or properties on an object in Twig, you use the dot operator. If you reference a property on a variable, a few different things get checked. If the variable is an array, then the key matching the property will be checked. And if it is an object, it will first look for a public property with the same name. If it can't find one, it will prepend the property with the words get or is and look for that method. So here, when you see us reference the timestamp property, we are really calling the getTimestamp method and returning the data from that method. Alright, let's take a look at how this all looks. Go to social.dev and log in. Notice how we are now sent to the user page? That is because if you now look at the home page route, If a user is logged in, we now send them to the Users page. Go ahead and enter in another URL. Now you see the URL showing up in our feed to the right. Great job! In this video, we added the ability for users to like URLs from a form on our site. In the next video, we are going to see how we can decouple the crawling of URLs from the processing of web requests using beanstalk-D. Welcome to the 6th video of this section, Allowing for Crawling to Scale. In our last video, we successfully integrated our HTTP URL service that crawls URLs for metadata into our web application. While this is great functionality, it is problematic that a request to our website could now trigger an external HTTP request. This could cause potential performance problems in our system. Because of this, it is a perfect candidate for using a job queue. In this video, we are going to move the process of crawling URLs to a beanstalk-D worker. First, we will learn a little bit about beanstalk-D and what packages we need from Composer to work with it. Then, we will review a custom provider we set up to allow using beanstalk-D in our application. Next, we will see how we can use Doctrine lifecycle events to trigger our own events in our event manager. Finally, we will create a beanstalk-D worker that will listen for new URLs to be crawled in beanstalk-D. Beanstalk-D is a very simple, easy to understand job queue. It would typically be ran on a separate server from your web server, but for simplicity's sake, we have installed it via Puppet on our VM. Once connected to the beanstalk-D server, you can place jobs in something called a tube. Then, other clients can be monitoring these tubes for new jobs, and when one is encountered, it could claim the job and take whatever action is appropriate. We will see how this works with our application shortly. In order to connect to beanstalk-D, you will need a Beanstalk client. The client we are using is called Beanstalk. You can check out Beanstalk's GitHub page for instructions on how to install it. In order to make using this with Silex a little easier, we will create our own custom provider. In the Beanstalk folder, open up Beanstalk Provider. In our register method, you will see that we are adding 3 objects to the container. First, we are adding a set of default configuration parameters. This should actually be all we need in this environment to be able to connect. However, it would be good to have the ability to override this for a non-dev environment. So in order to support configuration parameters, we have a config resolver. This will return an array containing all of the defaults, but it will override the defaults with any value set in the Beanstalk config portion of our provider configuration. This resolver is then used to return a client in beanstalk.client. If you open Social Application, you can see where we are registering the Beanstalk provider and passing in the configuration settings. The constants you see there are already defined for you in config.php, but could be overwritten if necessary in config.local.php. Now we want to add a job to Beanstalk anytime a new URL is added to our system. Doctrine includes a concept called lifecycle callbacks that allow you to execute a method on your entity when a specific persistence event occurs. If you open our URL entity mapping, at the bottom you will see we have defined a new lifecycle callback for the post-persist event. So whenever an entity is persisted, this method will be called. Let's see what this method does in URL entity. Here, we are loading a domain event manager and firing the new URL event with its object as a parameter. Domain Event Manager is a very simple event manager that we have created. There are lots of other event managers you could use, but for now, we just need something very simple, and this fits the bill. In addition to the getInstant method, it just includes a dispatch event method and an attach listener method. The attach listener method allows you to specify a callback that will be executed whenever an event is triggered. Events are triggered using dispatch event. The arguments passed to dispatch event will be forwarded on as the sole argument of the callbacks passed to attach listener. Now, in the URL directory is a URL crawler worker. This service will handle integrating beanstalk-D with our URL crawling process. At the bottom, you will see a simple queue URL method. This method is calling putInTube, which is the beanstalk-D method for adding a job. You can see it is simply passing a string URL. Beanstalk is always expecting a string. If you need a complex object, it may be best to serialize it yourself. The processJobs method is set up to watch the same tube we are inserting into. Then it executes a continuous loop that will attempt to reserve an item in the tube. The reserve method is how a worker claims a job. The parameter is the number of seconds the script will wait to receive a new job. If a job isn't returned within 10 seconds, then the call returns null. The getData method returns the string passed to the tube. Using that string, we can attempt to load a URL entity. If that URL entity doesn't load, then we will call the release method. This method allows the item to be pulled from the tube by another worker eventually. The second parameter is the priority, and the lower the number, the higher the priority. The third parameter is how long before another worker can pick it up. The default priority is 1024, so we are making the item available again in 60 seconds at the highest priority. If the URL was found, we pass it to our URL service and save the results to the database. If you take a look at our URL service provider, you can see how we trigger the jobs using our domain event. We are simply loading the worker from our container and calling queue_URL. Then, if you look in bin, you'll see a new URL crawler script. This script loads the worker from our container and just calls process jobs. So, now that we have this backgrounded using domain events, we no longer need to manually call the service. If you look at both fetch URL data and index.php, you will see that we removed the calls to the HTTP URL service, and they both simply persist the URL now. Now go to social.dev and log in. Then go ahead and add another URL. You'll see that the URL no longer has any details. Now, go to your terminal and execute php bin/urlcrawler.php. Now go back to your browser and hit refresh. There are your details. Excellent. In this video, we converted our URL crawling into an external job processed by Beanstalk. In our next video, we are going to allow our anonymous users to start consuming this data using Ajax long polling. Welcome to the 7th and final video of this section, creating a real-time global feed. In the previous video, we enhanced our crawling ability by leveraging a scalable job queue. In this video, we are going to allow our anonymous users to leverage our application to view the URLs that our users are sharing. First, we will make a few changes to our model to support pulling a list of the most recent URLs. Then we'll take a look at JavaScript we can put in place to pull the server for our new URLs. Finally, we will see how we can create a route to support long polling to get updates to our URLs into our users' hands as quickly as possible. We want to display the most recent URLs as they are added. In order to do this, we should make a few changes to our model. Open up our URL entity map. If you look at the bottom, we have added a timestamp. This will allow us to ensure we are getting the most recent URLs. We have also added a many-to-one relationship with users. This allows us to display who created each URL. Finally, we added an index to allow for quicker queries against the timestamp. We should also add a method to our repository that allows us to get the most recent URLs since a given timestamp. Open the URL entity repository. Here, you can see that we are using Doctrine's Query Builder. This is a tool that can make it a little bit easier to build dynamic queries using prepared statements. It might look a little bit daunting at first, and you might find that you prefer building the queries by hand. Personally, I would rarely, if ever, use this query builder for anything other than complex queries. In this case, we are creating a query centered around our URL entity. The expr method allows for us to build complex Boolean logic for our where clause. The and where variable is going to contain a list of criteria that must all be true. Basically, it is an and statement in SQL. We want to make sure that our URL status is set to loaded. This will only be true for URLs that have been fully crawled. Then, if a timestamp is specified, we are also checking to make sure that the timestamp of our URLs are greater than the timestamp passed in. We will then order the results by timestamp in descending order and limit the results to 10. Now we can call getQuery on our builder and return the results. In order to keep our list up to date, we are going to use a technique called long polling. The idea behind long polling is that when you make an AJAX request to your server, you actually block for an extended period of time until you have data to return. So if a user requests URLs after a particular time, we will return immediately if we have them. If we don't, however, we will continue checking on the server and only return once we do. This allows us to be more responsive to changes in the system. In order to handle this technique, you do have to use some JavaScript. Open index.html.twig. You will see at the bottom of the page a JavaScript function called pull. In this function, we are wrapping a jQuery AJAX call with a set timeout call that delays the execution by a second. Then we are calling /pull/new URLs and passing in a data attribute from our URL list. If you look above the script tag, you can see the URL list with the data last time attribute. You can also see below our list a URL template div with display set to none. We are essentially using this as a template to display our URL. Go back to the JavaScript and you'll see where our AJAX call is successful, it will update the last time to make sure that we don't keep pulling the same URLs. Then it will create a clone of our template for each returned URL, setting the appropriate attributes and text, and then inserting that new clone into our URL list once it is done. Then, it recursively calls the pull function to start all over again. Now, if you take a look at index.php, you can see the code that supports our long polling on the PHP side. We do a little bit of setup to get our entity manager and URL repository. Then something very important to note is that we close our session. If we don't close the session, then our AJAX call could block other requests from completing quickly due to session locks. Typically, these session locks aren't noticed, but we are going to be keeping our connection open artificially for up to 10 seconds. Now, you'll see a while loop that we will continue executing for that 10 seconds. In the while loop, we call our getMostRecentURLs since method and store the returned URLs to an array. If that array is not empty, we return it from silex as a JSON object. Otherwise, we sleep for a second and try again. So, from our clients, when we initiate the long poll, it will continue waiting for up to 10 seconds or until the URL is available. As soon as the controller returns, using JavaScript, it will initiate another request after a second. So, let's give this a try. Make sure you have both an incognito window open as well as your normal browser session. Do not log in from your incognito session. But from your regular session, go ahead and add a URL. Now you should see that URL pop shortly in the other window. There it is. Great job! In this video, we added a real-time feed of URLs to our site's homepage. In this section, we learned how we can use third-party libraries and frameworks to speed up the development of a new social sharing platform. We learned how we could use Silex to speed up that development time. We saw how to integrate with third-party platforms like Google. We gained some experience implementing forms through Silex. We worked a bit on creating services and service providers, and we even tackled a little bit of JavaScript and learned how to use it together with PHP to provide highly responsive interfaces. In the next section, we are going to continue building on the social aspects of our application with some of our newly found tools, as well as learn about a few more tools we can put in our tool chest. Welcome to the 8th and final section of letting users interact with each other. In the previous section, we created the beginnings of a social sharing platform. There isn't really a way for users to interact with each other, however. In this section, we are going to continue using some of the tools and techniques we have learned to this point to complete the social aspect of our sharing platform. We will see how we can implement a search engine into our project to help users find each other. Then, we will create a list of similar users based on users sharing the same URLs. Next, we will add support for following and unfollowing users. After that, we will allow users to comment on each other's URLs. Then finally, we will set up a feed for each user to see what is going on with the users they follow and the URLs they post. In this video, we are going to learn how to integrate a search engine with our site. First, we will review how to set up an index in Elasticsearch. Then, we will see how we can update our search engine whenever a new user is added. Next, we will create a repository to handle pulling users from our search engine. Finally, we will tie it all together by integrating the search into our site. Remember, using the social dev GitHub repo, you can check out the code using the tag for each video. Now let's go ahead and get started. We are going to be integrating a search engine called Elasticsearch. It is a very robust, very powerful search engine that integrates well with most languages, including PHP. We installed Elasticsearch onto our VM using Puffpit. Puffpit provides both Elasticsearch and Lucene as supported search engines. Elastic.co maintains several different client libraries that allow you to connect to Elasticsearch. We will use their PHP API, which is conveniently installable via Composer. Most search engines, including Elasticsearch, utilize their own data stores called indexes that hold data in a format that is optimal for various types of text searching. The population of this index is critical to the success of search. If you look at the search directory and source, you will see a new file, User Indexing Service. Open this file and you can see how we are able to populate our user index. Take a look at the reload user index method. This method will recreate our index using the data currently in the user's MySQL table. It starts by deleting our user's index. We do this in a try-catch, as the first time this method is run, the index won't exist. Then you can see how you create an index using Elasticsearch. I'm not going to give too detailed of an explanation, but if you look at how Elasticsearch performs partial matching in their documentation, you will start to understand more of what this configuration means. First, we are creating a user's index. The body of our create index request contains settings that control the analysis performed when both the index is populated as well as when it is queried. Here we are creating a custom trigrams analyzer that combines a lowercase filter with a trigrams filter. The trigrams filter is an n-gram filter that breaks each one of our words up into as many 3-character strings as possible. Trigrams is a concept common to natural language processing that we are taking advantage of here to perform very quick partial match searches against our usernames. In the mapping section, you can see that we are creating a user mapping that will contain a username property that contains strings that use our custom trigram analyzer. Continue scrolling down and you'll see that we then load all of our users out of the database and pass each of them to index user. Index user then uses our Elasticsearch client to store the user as a user type in the user's index. We are setting the username and then we also set the ID. The ID is important and just like in a database needs to be a unique value. We have created a reset indexes command line script that will execute the reload user index method so we can populate our index with fresh data. While it is great to be able to build the index from scratch, we also need a way to update the index when new users are added. We can use the same domain event concept we used earlier to trigger our URL crawler to also trigger an update to our index. Take a look at our user entity mapping file and you can see we added a new post persist callback. Now take a look at the callback in the user entity file and you can see that we are simply firing a new user event now in our domain event manager. Similarly to how we implemented the URL crawler listener, we have added a listener to the new Elasticsearch service provider. Here you can see that we are simply passing the user provided with the event to index user, and that's all there is to it. So now that we have our users populating and updating in our index, how do we get data out of the index? Go back to the user indexing service and check out the getUserIDs method. It accepts a query string and you can see that it searches for a user in the user's index where the username matches our query. The result array returned is a multi-dimensional array that contains quite a bit of metadata, but all we really need to return is the ID. To get from an ID back to a user entity, we can wrap this search method in a repository method. Go ahead and open the user entity repository. Here you will see a getUsersFromSearch method. It accepts a query and an instance of the indexing service. It then calls getUserIDs and using the returned ID looks up a list of rows. The results coming back from Elasticsearch are going to be ordered by the relevance of the result. so we want to maintain that order. We can do that by using usort. If you aren't familiar with usort, it allows you to sort an array using a callback method. The callback method will accept two parameters which correspond to two elements in the array. This callback method should return a negative value if the first parameter should be first in order, and a positive value if the second parameter should be first in order, and 0 if both parameters are equal. Then we can return the rows. Now let's take a look at our router. There is a new search route. In the search route, you can see that if a username is provided from the query string, we are passing that to our user repository to get results and pass them to our template. There's also a new script called userutility.php that allows us to add data to our site, so testing is a little bit easier. We are going to use create-user to create a couple of usernames we can search for. Alright, now let's log into social.dev and try out the search. You can see the users are now showing up. You can click through the results to see what they've been sharing. In this video, we learned how we could use Elasticsearch to index data for quicker full-text searching. In the next video, we will see how we can use some advanced doctrine queries to find users that like the same URLs as us. Welcome to the second video of this section, Discovering New Content. In the previous video, we learned how we could implement search functionality in PHP using Elasticsearch. In this video, we are going to continue exploring content discovery using our database. First, we will discuss a strategy for how we can identify users with similar tastes. Then, we will see how we can use actual SQL in our repositories to build and return managed entities. Next, we will learn how parameterized routes work. Then finally, we will tie it all together in our templates. Now, let's get started by taking a look at how we could find users with similar taste. The general idea of our site is that any user could at any time come in and add a URL. So one obvious way that we will be able to find users with similar tastes is to identify users sharing the same URL. We have a new command in our user utility that lets us add URLs to users. Let's use the like-URL command to add a few URLs to multiple users. Now, let's take a look at a SQL console file that has been created in PHP Storm to run some queries against our data. The SQL console can be found in the Database tab under the New menu. We want to pull user information, so we are starting with a query that just selects our user. Then we can get a list of the URLs shared by joining the user URL table on user ID. Next, in order to find other users that have shared the same URL, we can just join the user URL table again, but this time by the URL ID. We should also exclude our user ID from our queried user to make sure that we don't return our own user. Now let's execute the query. It looks like we are getting some data from this query. So how can we take this query and generate an entity using Doctrine? Go ahead and open User Entity Repository. You'll see that we have a getUsers with similar likes method that accepts a user entity. Here, we are using a Doctrine result set mapping builder to help us not just write our query, but also make sure that we build proper entities from the results. When creating a result set mapping, you associate the mapping to a specific entity class using the addRootEntity from class metadata method. You just pass it the class name of your entity, and then you pass it the alias you will be using for the associated table, which in our case is SU. Once you associate an entity, the result set mapping is able to build the select clause that you should use to get all of the correct entity data out of the table. We can use this in our query. The rest of the query looks very similar to what we used in the console. Now, using our Entity Manager, we can create a native SQL query object by calling createNativeQuery and passing it both our query and the result set mapping builder. Now, we just need to assign our parameters and call getResult. This will query the database, and then using the data put together by the result set mapping builder, Doctrine will be able to determine how to build the entities that got returned by getResult. Now let's take a quick peek at our router. We are going to use this new method to display a block of similar users on our user homepage. The code for this is in the user route and is very simple. We just get a copy of our repository and then we call the new method with the logged in user. If you take a look at the user/index.html.twig template, you can see where we list the users. You'll also notice a link that is generating a public user URL using a parameter. Go back to our router, scroll down, and you will see our public user route. Take a look at the definition for the route, and you can see an example of parameterized routes. You can use curly braces to specify where in the route a parameter would go, and then that parameter is made available to your router action. As you saw in the user index template, you can generate a URL with parameters. It will properly copy the parameter value into the appropriate place in the URL. Now let's give this a try. Go to social.dev and log in. You can see that the related users are on the right. Go ahead and click on one and you'll see a list of that user's URLs. In this video, we discovered how we could use SQL in conjunction with Doctrine to discover similar users on our site. In the next video, we will add the ability to follow and unfollow users. Welcome to the third video of this section, User Following and Unfollowing. In the previous video, we added the ability for a user to find other users that are posting the same content. In this video, we will extend that functionality to allow you to follow related users as well as unfollow them. We will start by taking a look at how we are going to map our user following concept to the database. Then we will go ahead and implement the user follower entity. Finally, we will integrate it with our router and see how we can use Flash messages to easily communicate notices to our users. Alright, let's get to it. Open up our mapping directory and you'll see a new user follower entity. We are really just going to map a handful of data. We need to understand who the follower and who the followee is. Both of these properties will be instances of user entity. These properties together will form our key. We haven't really mentioned this before, but if you're going to use a foreign entity as a part of your ID, you can specify an association key as true in the ID section. This tells Doctrine that you want to use the ID of the related entity as the component of your key. The only other column is just a timestamp. If you look at the user follower entity, you will see that it is a pretty simple entity, but it does have one static method, unwrap followed users. We are going to want to list all of the followed users on our user homepage. It would be great if we didn't have to jump through a bunch of objects to get the user though. So we have added this convenience method that takes a list of user follower entities and returns an array of followed user entities. Alright, now head over to index.php and we will see how we add this data to our user homepage. It is simple really. We are just using our user follower repository to retrieve user follower entities where the current user is the follower. Then we unwrap them. We don't want to display the same users as both a similar user and a followed user. So we can use array_diff to return all similar users entities that are not in the followed users entity list. Now you see that we are calling getFlashBag on the session. What is that? Well, a flashbag is a location where we can store data that only lives across the lifespan of a redirect. Scroll down and you can see in our new follow user route how this works. In our follow user route, we are loading our followee by the username passed in on the path. Then we are checking to see if a relationship already exists between the two users. If it doesn't, we establish one using the follow user method on the user, which creates a user follower entity. Then we persist and flush the entity. You'll notice in 3 different places we are using the add method on the flashbag. This is going to cause this data to be written into the session. Each key in the flashbag holds an array of data. When we redirect to the user route, this data will be available for that request on the same keys. Take note of how we treat it like an array. As a part of processing the flashbag, these keys get removed. So let's take a look at how this works on the site. If we go to our site and log in, we should see our list of similar users from the last section. Now go ahead and follow one. As you can see, we are getting a success message from our flashbag. At this point, the message has been deleted from our session. So if I refresh the page, you will no longer see that message. Flashbags are a great way to communicate data across redirects without adding query string parameters or having to manually maintain the transient session data. So let's follow another user, and now maybe we can try unfollowing one. It looks good. In this video, we successfully added the ability to follow and unfollow users, and in the process learned about some cool session functionality in Silex. In the next video, we are going to learn about embedding controllers while we create a real-time comment stream for our URLs. Welcome to the fourth video of this section, Create a Real-Time Commenting System for URLs. In the previous video, we rounded out the ability for users to discover and follow each other. In this video, we are going to add the ability for our users to communicate with each other. First, we will look at the changes we will be making to our model to support commenting. We will concentrate a little bit specifically on how our repository will be leveraging Doctrine to pull data from the database. Then, we will take a look at the changes we are making to the router to support comments. Finally, we will learn how we can use HMVC to make our comments more modular. Let's get started by briefly looking at our entity and mapping. In the URL comment entities mapping file, we can see that we are going to use a single table URL_comment. It will use an auto-generated ID and will store the comment as a text column, timestamp as an integer, and will hold references to the author as a user entity and the URL as, of course, a URL entity. Since we know we are going to frequently query this data by URL in a timestamp-based order, we can also add an index to represent that. If you look at the URL comment entity, you'll see that it is a very basic entity. There is not a lot of functionality we need for comments right now. So let's look at the repository for URL comments. Here we have a method getComments for URL after. It takes a URL as well as an optional URL comment entity. The purpose of this method is to return all of the comments for a particular URL that occurred after the passed-in comment. This will be used to help us create another long polling feed for comments just like we did for recent URLs. As you can see, we are using a query builder again. We'll alias our URL comment table as comment. Obviously, we will want to select everything where the comment's URL matches the URL passed in. Then, if the comment is empty, we just return the data ordered by timestamp ascending and then URL comment ID ascending. So when we have a comment passed in, why not just select any rows where the timestamp is greater than that of the passed-in comment? The problem with this strategy is that it is possible that two comments were added in the same second. If you only selected things greater than the passed-in comment's timestamp, then it could feasibly miss on a comment that came in immediately after the passed-in comment. So, instead, we return comments with a timestamp greater than or equal to the passed-in comment's timestamp. Then, we further break it down by saying that either the timestamp must be larger, or if it's equal, then the comment ID must be larger. This will guarantee complete uniqueness in returned comments without skipping comments. Alright, let's take a look now at our new route changes in index.php. We will need a place to add comments to URLs, so we are going to introduce a new URL details page. This page will display information for the current URL. It will also be the redirection point for successfully adding a new comment. Because of this, we will use a flashbag to communicate success or error messages back and forth. Next, we have a comment route. This will pull the URL as well as the comments for that URL. We are using our custom repository method, but we want all comments here, so we are not passing a second parameter. Now, we have a post route to add comments. This is a fairly simple, easy route to follow. We are loading the URL, adding the comment from the request, and then redirecting to the URL's detail page. Finally, we have a polling route. This will be used to keep our comment stream updating in near time for each URL. This is similar to the polling route we did for our anonymous URL feed. You can see here we are passing a comment object to the custom repository method. Now let's take a look at URL comments.html.twig. So you may notice something strange about this template. It's not a full HTML page, nor is it extending another page. This is just an HTML fragment. We don't actually intend for anyone to access this page directly. We would instead expect them to view the comment list from our URL page. Open URL result.html.twig. Scroll down a bit and you can see a new twig method called render. This is using the HTTP fragment service provider to embed an internal route onto your page. No network calls happen as a result of this call. It simply mimics a request using the same application container and spits out the HTML to that location in a page. This is a concept known as Hierarchical Model View Controller, or HMVC. Really, it can be viewed as just embedded controllers. It is very beneficial in helping you to create a very modular plug-and-play interface because you don't have to spend time every time you want to use the interface setting up all of the data for the controller. You just include the entire controller. Log into social.dev and choose one of your URLs. Let's add a comment and you can see our comment now refreshing. If I go to the route that points to the URL fragment, you'll see that fragment appear. Now let's go to the user homepage. Go back to PHP Storm and copy the render function. Now go to the user index page and paste the render call into the URL list and update the variables. Go back to your browser and hit refresh. As you can see, all of the comments for URLs are now showing up. We can add this functionality to any page of the site with little to no effort. Pretty cool. In this video, we learned how to leverage HMVC by implementing a comment feed. In our next video, we will be adding domain events to power a new user-specific feed on the site. Welcome to the fifth and final video of this section, Creating a Feed for Users. In the previous video, we used HMVC to add comment streams to our URLs. In this video, we will create a user feed that allows a user to keep up to date with information flowing into our system. Much of this video will really be driving home some of the concepts we have been learning throughout this project. We will review how to set up our feed in the database and how our entity is mapped to that database, as well as how we pull feed data from the database. Then, we will review how we can use our user entity to create new feed items. Next, we will walk through how we can again use events to determine when we should add items to the feed. Finally, we will take a quick look at how we updated our routes to include the feed data. For our user feed, we are going to track 4 different user interactions. We are going to track when a user comments on one of your URLs, when a user you follow comments on any URL, when a user shares the same URL as you, and when a user you follow shares any URL. Let's take a look at the feed item entity mapping file. We are going to use the feed item table to hold all of our feed data. Our feed is fundamentally going to work around the concept of actions a user takes against a particular URL. So we are going to join 3 different entities. The user property will be a user entity to indicate whose feed an item belongs to. The author property will be used to indicate which user entity's action caused the feed item to be created. And the URL property will be used to indicate which URL was acted on to create the feed item. In addition to this, we should also include a separate set of fields to control the description, the image that will be used in the feed, and the URL that the feed item will link to. Then, we should also include a timestamp so we can sort the feed items correctly. We could glean a lot of this information from the joined entities, but keeping it separate allows us to better control how we display the feed. For instance, we probably want to show the image associated with the URL when a followed user adds a new URL. However, if a user we did not follow comments on one of our URLs, maybe it makes more sense to show an eventual avatar for that user. By keeping these fields separate, we give ourselves that flexibility. Let's check out the entity we are mapping here. open feed item entity. You can see we have embedded a bit more logic into this entity. For instance, in the description, we are supporting tokenization of the descriptions. This allows us to ensure that the most updated data is displayed in the description. The token's author and URL can be stored in the database. And then, at the time we pull the description from the entity, we can fill in the appropriate blanks. So, if a URL title changes, the feed description would automatically change as well. We have also included a method that allows us to generate a URL. Instead of storing an actual URL in detail URL, we will store a route name followed by query string parameters that map to action parameters. We can use generate URL to then use our app container to generate the appropriate URL in the system. This is better than storing a static URL, as it is possible that we could change our URL structure at some point. We would want our feeds to also update accordingly. Everything else in this entity is pretty straightforward. We can take a peek at the entity repository. Here we have a method to pull the 10 most recent feed items since a given date. You can see we are using a query builder here. This should be becoming a bit more straightforward to read now. We are just querying feeds where the user equals the passed-in user, and if a timestamp is provided, the timestamp of the feed must be greater than the passed-in timestamp. Then we are ordering the feeds and returning a maximum number of results. Now, let's look at how we create new feed items. Since feeds are really targeted for an individual user, it seems to make the most sense to add methods to the user entity that can then be used to create feed items. Go ahead and open the user entity. You'll see that there are 4 new methods. One method for each type of feed item we are going to support. The add followed user liked URL to feed accepts a liked URL entity. We will use the user in URL for the liked URL to build our feed item. Take note of our parameterized description and how we are using a route name with parameters to define our URL. Finally, we copy over the image from the URL. So how do we know when each of these methods should be called? This is another perfect place for some domain events. If you look at the liked URL entity, you'll see that we have added a new post_persist event for that entity to trigger a new domain event. We did the same thing for URL comment entity. Now look at the feed item service provider. You can see we have registered 2 listeners, one for each of our new events. In the liked URL event, we are determining who all is following a user that liked the URL. We then unwrap those users, and using those users, we can call add followed user liked user to feed, and pass it the liked URL. Then we can also use the liked URL to find everyone that has liked that same URL. We can unwrap those users and call add user sharing same URL. You'll see we are doing something similar for users adding a new comment. Now if you go to index.php, you'll see the changes to routes are very simple. In our user route, we are just loading feed items from the repository and passing them through. Then we have another pull route to handle the long polling for our feed. Now we can use our user utility to comment and like some URLs. I'll just add a URL for some users that I follow, and then I'll add a few simple comments to those URLs. Now, if I go over to my homepage, you'll see that they are showing up. Great job! In this video, we have added a user feed to help our users keep up with what is happening on the site. That concludes this section. We have made some great progress on improving the interactivity in our social sharing platform. We learned how to integrate Elasticsearch into our application through adding a user search. We learned how to use Doctrine to build complex queries using plain SQL to generate Doctrine entities for finding users posting the same URLs. We learned how to implement Flash messages to communicate success and error on operations such as following or unfollowing users. We learned how to leverage HMVC to encourage modular design when adding comments to a page. Finally, we learned how we can tie disparate events together into a single feed in an easy-to-extend way. We have now reached the end of this course. Over the past 8 sections together, we have progressed from creating a basic URL sharing utility to an authentication management platform through to a full-fledged social sharing platform. Along the way, we have covered many different techniques and technologies that you can hopefully apply to your own projects in the future. Feel free to continue playing with the example projects in this series. There are lots that can be done, from added functionality to cleaning up duplicated code. I wish we had more time to cover some of these topics in more depth, but hopefully you now feel empowered to begin digging deeper into the specific areas of these videos that were appealing to you. Thank you for watching, and I wish you the best of luck in your future PHP projects.